In this tutorial, I'm going to look at some of the entities which typically make up an e-commerce application. So we're talking about products, orders, and items. I'm going to show you how to create these using Doctrine ORM, how to establish a relationship between them, how to test their creation and test that relationship. And so a lot of the work will be done using Doctrine ORM in PHP. A lot of the work will be done in PHPUnit, where I'll also show you how to create in-memory test databases, how to write your own custom assertions, and how to test the creation, removal, and the linking of those items mentioned. This collection of recordings was originally planned for a larger e-commerce project, but for various reasons I decided to split out the work which was done on entities and on testing, and I think they stand on their own as a pretty good project if you're learning those things. So hope you enjoy it. If you do have any comments, questions or queries, then leave those below the video. Enjoy! Okay, so in between finishing the last recording and starting this one, I had a bit of a think about the way we're going to take this project forward. And I made two decisions really. The first one is, rather than do some learning and then work on mini projects, what we're going to do is we're just going to work on one big project. So we'll do some learning and then we'll go and apply what we've learned to that project. At the time of this recording, I'm thinking either software as a service or e-commerce, but I've still not totally made my mind upon that. The other thing I'm thinking is that rather than use PDO like we did in the first course, we're going to do something which is more typical of what will be used in the industry, and we're going to use something called Doctrine ORM. ORM stands for Object Relational Mapping, and basically what that means is you're creating objects, classes which map to tables in the database. So it's a bit of a pain, but what I decided to do was, because we're making these changes, start a new project. To get up to speed and to get to where I am at, all you need to do is copy my composer.json file, which you see here, pulls in various pieces, file dumper and PHPUnit, which we did in the first recording, and then also we've got these new ones here, which the main one is Doctrine ORM. Okay, and then once we've done that, we're going to go over to the Doctrine documentation, and we're just going to grab some code from there, which we'll use in a bootstrap file, and then I'll talk you through how we're going to take it forward from there. So let's start off by pulling in these dependencies. I've called my project BTB-project. Okay, and so over to the terminal. And in the root of that project, I have my composer.json file. It's the only file I have in there at the moment. So composer, and then install, and this will install all of those things. So that should take a second. Okay, great stuff. So let's go and check out our vendor folder. And there we go, there's all our dependencies. I do tell a lie, I have one other folder in there, and that is an SQL folder, and we have the user SQL that we looked at in the previous lesson. So in this one, we're not actually going to be creating the user table directly like using SQL here. We'll use the entities and use something called annotations. And what we do is we run a command from the command line, and that will read an entity file. So we'll have a user class with various properties. It'll read that class and actually create a table in the database from that. So all clever stuff, you'll get to see that shortly. First off though, we need to just nip over to the Doctrine documentation and grab some code, some configuration. Okay, so this is the doctrineproject.org website, and we're just going to grab some code from the getting started part. I'd recommend you have a read of this if you've not used Doctrine before. Maybe work through this little tutorial, and then you'll have a good idea more of how it works. My lesson isn't going to be a Doctrine lesson per se. I'm going to show you how we can achieve what we want to achieve with Doctrine, but if you want to go into it in more depth, then this is the place to go. And so it tells you what is Doctrine. It explains it's an object relational mapper, so you're mapping PHP objects to tables in the database. And a good thing about it is that This creates that separation, so your code, you don't have to write code which is specific to MySQL or Postgres or Oracle. You just simply write PHP code. In your config, tell Doctrine which database you're using, and Doctrine will actually convert your PHP code into either Oracle SQL or Postgres SQL or MySQL. So really clever, really portable, and it means you're not tied into using just one database vendor. Okay, so as you can see here, project setup, we've already got these parts here. We've pulled in Doctrine ORM and Symfony YAML, even though I'm not sure we're going to be using Symfony YAML. But the bit we're looking for here that we're going to copy is this bootstrap file, and what this does is it does all the configuration. It's going to, if you see this line here, it's going to tell Doctrine to use annotations to create the metadata, and it reads that metadata to create the tables and to read and write from the tables. Okay, so all good stuff. Copy that, then back over to our project, and then in the project root just create a file called bootstrap.php. So bootstrap.php. In fact, I don't need to put .php because it's creating a PHP file anyway. And then I'm just going to paste that in there. Okay, so I'll talk you through some of this. So the setup is a class which is used to do the configuration of Doctrine. Entity Manager, that's we're going to create an Entity Manager object actually in this file, and then we'll be able to use that in all files which require or include this one. And the Entity Manager is the object which reads and writes to and from the database and handles all the persistence. So autoload, you know all about that. We're using the Composer autoloader. Here we're saying that we're in dev mode, so maybe later on in this course we'll actually switch from hard coding stuff like this to using environment variables, where we're reading variables from the server. Okay, proxy directory cache, not too sure about both of those things. Use simple annotation reader. This is just some default configuration. This next line though, this is important because what this is doing is it's telling Doctrine to use annotations for metadata configuration, and we're also passing in some config into that to help set that up. Okay, and so what that means is we don't need these next couple of commented out lines because they are for if you want to use XML for your metadata configuration or YAML for your metadata configuration. We won't be using those. And then we come down to here. So the default is an SQLite setup, but we're not going to use an SQLite setup. We are actually going to connect to a MySQL database. And so what we'll do is we'll put the config in here now, and then we'll go over and actually create the database that we're going to use. So I've added practice earlier on and I figured out my config, so I'm just going to go and copy and paste this and update it from another file. Okay, so I'll paste that in there. So the driver will be PDO MySQL, so it's using PDO for MySQL under the hood. Our user, I'm just going to have a username of root. Password, I'm going to leave blank. It's not going to be BTB practice, we're actually going to call this BTB project. And then the host will be 127.0.0.1, i.e. localhost. And then this is where the entity manager is created, and so this is what we'll use in all files which include this one. Okay, so I'm over on Table Plus, and just to show you my MySQL connection, I can call it what I want, but the main thing we're looking at is the host, and that of course matches the host that I'm using in my Bootstrap file. What else we're looking at? Port 3306, which is pretty standard for MySQL. User is root, okay, so that matches, and password I left blank, and so this is all good. We can connect to this. And then I just need to go and actually create a new database. So on this little thing here, I'm just going to click this little plus, and we said it's called BTB project. So BTB, by the way, stands for Beyond the Basics. I think you probably know that by now. And the encoding, it's the one I actually want is UTF-8MB4. and then it'll fill in the other bit for me. Click OK, and then I'm just going to open that. And so I have an empty database, no tables in there yet, because the tables, as we said, is going to be when we create that entity file for our user. We'll run a command from the console, and then magically it will create a table from reading our PHP, which is pretty cool. What do we need to do next? Let's have a look at the Doctrine documentation. And so it says here, generating the database schema. Doctrine has a command line interface that allows you to access the schema tool, a component that can generate a relational database schema based entirely on the defined entity classes and their metadata. For this to work, a CLI-config PHP file must exist in the project root directory. Okay, so let's create one of those. We need to copy this, go over to our project, and then we're going to, I think it's called CLI, let's have another read of that, CLI config. And then we'll paste that in there, and it's giving me a squiggly line because it's saying PHP Storm saying undefined variable entity manager, but we're actually requiring our bootstrap file. So we do have that entity manager variable available to us. So I'm just going to disable this inspection and also get rid of the squiggly lines here. Okay, so we'll have a quick look at the bootstrap file. As you can see, we created an entity manager object there. Okay, so it's using like a factory method here. If you recall when we worked on factory method in our design patterns, so it's using a factory method here to create us an entity manager, and then because we are including or requiring that bootstrap file in our CLI config file, we now have the entity manager available to us. And so we can actually go and run a command which will create tables from any entities that we already have in our project. We don't actually have any in our project just yet, but we can run the command and it will Doctrine will let us know that we don't actually have any entity files created yet. But just for thoroughness and to finish off this first recording, let's give this a go. So vendor bin doctrine ORM schema hyphen tool create, and then this should create us anything it needs to create. Okay, so I understand what's happened here. If we go and look at our bootstrap file, we actually said that our directory that we're going to create our mapping from will be this src directory. And so it's saying file mapping drivers must have a valid directory path. However, what's missing? We don't actually have that src folder. So in the project root, you need to create an src folder. And this is where we're going to create all of our entity classes anyway. And so src, it should be a little bit happier now. Let's go over to the terminal and run this again. Okay, great. So this is perfect. It's saying no metadata classes to process. So like I say, we've not created any entity classes just yet. We're going to do that in the next one. Okay, in this one we're going to build on where we started. In the last one we created our configuration for Doctrine, and so we're going to create a user entity. Little thing I thought about after I finished recording in that one was the composer JSON file. So the versions I'm using here, what I'd recommend is you just copy what I've got here, all the same versions, because what you tend to find is students install their own versions, they have different versions than me, we get out of sync, and then you spend more time trying to debug their problems when they have compatibility issues. So if you stick with the versions I'm using here, and then as the project progresses, if say for example there's going to be updates, then we'll actually do it together. I'll update them as part of the lesson, and then we're all singing off the same song sheet at least. Okay, so that bit out of the way, let's now go and create an entity. So we've got our autoloader mapping here. We're mapping the app namespace to the source folder. So we're going to go in the source folder and we're going to create another folder inside of there called entity, and then we're just going to create a PHP class called user. So let's go and do that now. So source, and then inside of there we want a folder called entity, and this is like a fairly common folder mapping. This is pretty much exactly the same as what you use when you use Symfony. You have a source folder, and inside of there you have an entity folder. And so we now need a user class. And by the way, don't worry, don't get too concerned that we're using things like Doctrine and thinking it might be a little bit over your head. Doctrine's quite a standard tool. Throughout your career as a PHP developer, you will come across it at some point. I'm going to show you the basics enough for us to use it in this one, but like I said in the last lesson, if you want to go deeper into it, either check out some of my lessons on YouTube, because I've done a few there, and also just go through the documentations, go through that tutorial which I showed you in the last lesson. Okay, enough of me waffling on. Now then, we need to have a look at our SQL, and then we'll copy the properties from there. So this is like how I'd work. I'd just look at it one step at a time, maybe do a model of how I'd like my tables to look, and then just copy that. So we're going to need these four properties here: ID, username, password, created at. Good idea is to just copy that, go down to here, create a comment, and just paste it in, and then at least we've got some kind of guide. Okay, properties need to be either protected or private. Okay, don't make them public when you're using Doctrine entities. So I'm just going to make all mine private. So private, and this is going to be ID. I'm just going to make a little bit of space here. Okay. Then we've got username, then we've got password, and then we've got created app. I'm going to go with camel case, and I'll show you how we can actually translate that to snake case for the database. Okay, and so now we have our properties. We now need to let Doctrine know to treat this as an entity, and so we need to pull in the mapping classes that we're going to need for this. The way you do this, and this is pretty standard, is we use something called mapping. Okay, and this comes from Doctrine ORM mapping, and then you give it an alias as ORM. Again, this is standard practice. You'll see this anywhere where Doctrine is used in their documentation in Symfony projects. This is how you do it. Okay, and now we need to tell Doctrine, hey Doctrine, this user class, please treat it as an entity. The way we tell Doctrine to treat this as an entity is like this. So we add a doc block above the class. Just going to remove the default comments, and we'll stick with our own. So I type at, and then if I start typing entity, it should come up. And so if you see this here, ORM / entity, and that is Doctrine ORM mapping entity. That's what we need. Don't need to give it any arguments there. Now we have told Doctrine that this user class is to be treated as an entity. We'll tell it the table name, because I've called the class user, which means I think that would default to calling a table user. However, we're going to go with users, I think, only because I've seen in the Doctrine documentation they use plural for their examples. It really doesn't matter. I think the split is 50-50. Half the people think it should be singular, the other half think it should be plural, and nothing standard has ever been agreed. But we're just going to stay in sync with what Doctrine does on their documentation, I think. So we'll call this users. And now that is, I've now told Doctrine treat this user class as an entity, and that the table it should map to should be called users. We now need to add annotations to each of our properties, and so ID, we need to let Doctrine know that this is the ID, i.e. the primary key, and the way we do that is simply at ID. So ORM ID, we don't need to provide it with any argument again. Then we'll say the column type, so we'll start typing column, ORM column, and type, and the type will be integer for this. Okay, as you see, I'm getting a bit of auto completion there. Then we need to tell it how to auto generate the values, and we just the default is for it to recognize that you're using SQL or PostgreSQL or Oracle, and it will use the default strategy for that vendor. So in MySQL, it will use auto-incrementing IDs. In Postgres and Oracle, it will use sequences. So quite clever. If you don't tell it to do it a particular way, it will just automatically choose what that vendor does by default. And what we're looking for is this ORM generated value. We'll go and look at this just to show you what I'm talking about. So final class generated value implements annotation. So these are all instances of annotation of the annotation. Okay, and so here are the different types of generators. Default is auto, as in automatically choose the strategy which your vendor uses, and so we're just going to stick with that default. Okay, good stuff. So that is the ID taken care of. Now we need to move on to the username, and the username is going to be a string, and so at ORM column, and then type will be string. Okay, perfect. And we can copy and paste that for password actually, because we're going to use the exact same thing there. Okay, created that. So the column type for this is going to be datetime. We're actually going to specify a datetime interface for this, and I'm using datetime interface in case we use a combination of datetime and datetime immutable. Okay, and so ORM column, and then the type is going to be datetime. Okay, and we also, because I'm using camel case here, but in the database I want it to be date underscore, created underscore at, so we're going to say the name of the field in the database will be created at, like that. Okay, and so that is our properties done, and that is how you let Doctrine know that you want the user class to be an entity, you want this ID to be an auto-incrementing ID, you want the username to be a string, you want the password to be a string, and you want the created at field to be a datetime. Okay, perfect. Let's add some getters and setters now. Before that, if we think about when we create a user, we want, every time we create a user, we want to use the current date time to be used when it's saved in the database. So what we shall do for that is, in the constructor, we shall just say this created at equals new date. I'll go with datetime immutable. And now we're going to create our getters and setters. I'm using PHP Storm, so I can automatically create them. If I hit Control and then Enter, it'll bring up this little generator menu here, and just there it says getters and setters. So I'm going to create them for all, hit Enter, and so that's done for me. I'll just put my datetime interface type declaration in there, and then we'll go and just check that everything is okay. So everything is there. There's one thing that we do need to change. We don't need to set the ID. The ID will always be set by the database. But apart from that, our entity is looking good. Let's just go down here, get ID, get username, set username, get password, set password, get created at, and set created at. Okay, perfect. Now what we need to do is create that table in the database. So let's go over to the Doctrine documentation, and this is the command here. It says now call the Doctrine command line tool, and it's vendor bin Doctrine ORM schema-tool :create. So it's the same one that we ran in the previous recording, but this time we now actually have an entity which should be persisted to the database. So let's roll this with our fingers crossed, hit Enter, Okay, so database schema created successfully. Ignore this message here. If you see that, that's not relevant to us at this moment. The good bit is this bit here, database schema created successfully. So I'm going to go over to Table Plus and I'm going to give this a refresh. Okay, we now have a users table. Let's just go and make sure it's been created correctly. So I'm going to look at the structure. ID, auto incrementing, username, varchar 255, password varchar 255, all of them are not nullable and created that as a datetime, and if you notice it created it with the name that we specified. So far so good. Now let's go and create a user. Okay, so let's go to the root of our project and we'll create a little utility. So in there I'm actually going to create a little folder called utility, and in here we can put any little utility helpers, any little command programs, stuff like that. So utility, and then I'm going to call this create user. So just create a normal PHP file called create user. It's not a class, it's just a normal PHP file. And what this is we're going to execute some PHP from the command line, which runs this script. And this script, what it's going to do is create a user entity, set a username, set a password, and then using Doctrine ORM, or using the entity manager from Doctrine ORM, we're going to persist that to the database. And then we'll go over to the database and just check that everything has worked. Okay, so first things we need to do, we need to require our bootstrap file, because we can't use the entity manager without that, so we shall require once. Now I'm going to actually run this, whenever I run these utility files, I'm going to run them from the project root. So that means I'm not going to do this kind of thing where I'm going up and looking for the bootstrap file. I'm just going to, because I'll be running it from the project root, I'm just going to write it like this. Okay, and so we're going to provide some arguments to this little command line script. So it'll be PHP create user, and then we need to supply a username and a password in that order. So the way you can do this is you can actually unpack the arguments like this. The first one will always be the file name, and then it will be username, and then we're going to provide a password, and that is going to be retrieved from argv. Okay, so argv is the command line arguments that are picked up when we run this script, and so the first one will always be the file name, because that's what we're going to provide first. PHP create users. Okay, so in fact, before we go any further, let's actually take this for a test drive and we'll dump that out. So require once and vendor autoload.php, and we're just going to use the Symfony var dumper to dump out the file name. So it'll complain about something here, and we're just going to disable that inspection. Okay, let's go over to the terminal. So PHP utility create user, and then we're going to provide a username. So I'll just put Gary for now, and a password, pass. We just want to see that it's working so far. Okay, so we dumped out the file name. Let's actually dump the lot out. Username, password. Okay, we'll try this again. Okay, so we know that's working, so we can now grab the username and the password and use those when we create our user entity. Okay, our next step is to create a new user. So user equals new user, and it's just like creating any other kind of class. Even though we've said, okay, this is an entity, it's just the same as any other class. That hasn't actually changed the way that it works in any way. All it does is that metadata, it just speaks to Doctrine and say, hey, treat this as an entity for your purposes only. Okay, so we now need to hash that password, because it's going to be in plain text, which we're just going to use a plain text password. We need to hash it in order to store it in the database for it to be secure. So hashed password equals, and then it's password hash. Okay, then we need to provide the password as the first argument and then the hashing algorithm as the second argument, which in our case we know with password default, and that should give us a hashed password. In fact, we'll dump it out. We'll just dump it out each step of the way so that we're in total control of what we are doing, and also so that you can follow this lesson. Okay, so now we have a hashed password. Things are going well. What do we need to do next? We need to set the username and the password. So user, what am I doing? User set username, and that will be the username, and then user set password, and that will be the hashed password because it's the hashed password which we are saving in the database. Okay, next step, we need the entity manager. Now we're getting it from the bootstrap file, but I'd like a bit of auto completion, so I'm going to do something a little bit strange here. I'm just going to say em equals entity manager. Okay, so a little reminder, we know we've got the entity manager available to us, because if we go and look at our bootstrap file, and in fact bootstrap, the very last line here, we created an entity manager. We are requiring this file, which means that that variable is available to us. The only reason I'm doing this is so that I can have a bit of auto completion. So if I do this, entity manager. Okay, so now when I do em, a little menu comes up. I've got some auto completion, which I'd recommend doing things like that because it's a lot of commands to remember. It's easy to type them wrong. If you have that auto completion, then all you need to do is select something from the menu and you know that it's going to be correct. You're not going to spend ages looking for little typos and stuff like that. And so the way this works is we choose entity manager persist, so the persist method, and all this does, it just brings the object which you supply as an argument under the entity manager's control. At this point, you're not saving anything in the database. You're just saying, hey, entity manager, I'd like you to know about this object. And now the entity manager has control of that object and it's ready to perform whatever you need to do with it, whether you want to update records, delete records, you do it all with one command. So you could have a load of records which you're doing various little bits and pieces with. You're updating one, you're creating another, and then it's optimized so nothing will actually happen. No database records will be created until you call entity manager flush, and then Doctrine will work out the best and the most optimized way to actually perform those queries. So it's all pretty clever, and can you imagine actually trying to create something like this yourself? So this is why we use third-party packages, and it's all a mishmash of all the best of all the tools that you can get from Composer, etc. So entity manager flush, and this will now persist our user in the database, and then we'll just print out a little message here at the bottom. So echo, and we're just going to say created user with ID, and now that we've done this, we can actually get an ID back for the user. So user get ID, and it will give us the ID that it has been saved with in the database. So that's pretty cool. Let's go and test this out. So we've run it once, and I'm going to go with username of @GaryClarke and the password will be secret. So let's give this a go. Created user with ID 1. This is looking promising. Doesn't always work first time, by the way. In fact, often there's usually something that you've done wrong first time, but that's not a problem. It's all part of software development. Let's give this a refresh. Okay, this is looking pretty good. So we've got, I didn't mean to rearrange those then. Just going to make a bit of space here. So we've got our hashed password, we have our username, we have the created @, so it uses the current date time, and it gave it an auto incrementing ID of 1. Okay, now let's have a look at how we can make our application work together from end to end. We'll think about the customer journey. It's e-commerce, so we want to see what the experience is, what the journey is for purchasing a product. And so the best way to do that is to simply just go and find an existing e-commerce site or a couple of e-commerce sites and just make that journey yourself, and then you can make the notes, figure out what your requirements are, and that will drive what you actually build, what your entities will be, what database tables you need, what pages you need, etc. So we'll start probably the biggest, Amazon. Here I'm not signed in. I'm just going to go and look for some products and see if I can actually put stuff in a basket and buy it. So we'll just go for, I've got a bit of a thing for electric drum kits at the moment. I'm thinking of buying one so I can combine a bit of research with actually teaching this stuff. So here's a bunch here. We'll go and stick the first one we see into the basket if we can. Add to basket. In fact, we'll click buy now. Okay, and so it takes me to this page. It's saying I've got to sign in. Let's just go back. We'll add to the basket, see if it's any different here. We've added that to the basket. It says I've got 2 items in the basket now. Let's proceed to checkout. And again, you've got to be signed in to buy stuff on Amazon by the looks of it. eBay, however, I recall having made purchases as a guest in the past. So let's see what this experience is like. Again, just going to do the same thing. Click on something and I'm going to choose buy it now. Okay, so this is what we're looking at. Sign in for checkout or checkout as a guest. And so it looks like I can just put in my details and then choose a payment option. Let's just take you one step further. Obviously I'm not going to buy this. Okay, so it looks like I can put my details in, put my card details in, and then I can buy that as a guest without actually needing to have an account. Okay, so a bit of food for thought there. Now let's actually go back and sort of work through that again. Look at the steps we took, look at the pages that we're looking at. So one consideration is, I mean, eBay, Amazon, they're obviously general stores. You can buy literally anything on there. I think what will be better for us if we have something more focused, and maybe I can just combine this with my new electric drum kit research and just have something which specializes in something like that. And so initially you'll have a products page. Let's scroll all the way to the bottom of this because there's something I want to check out here. Okay, they've obviously got hundreds and hundreds of these things, and so if you get to the bottom we have pagination. So thinking about this, we'll have a products page and we'll decide that we're going to show so many per page, and then we can paginate onto the next page. And then what you do is you click on something you're interested in, and that will take you to a specific product page just for that one single item. And then you have a few options here. Obviously we're not going to get into all this stuff that eBay has, but we want to be able to either, I think both these options will be good for our site, either buy it straight away or add to a basket so that you can go and look for other items. In fact, we'll do that because that's something I'd like to do. So we'll add that to the basket, and then we'll go and look at something else. So go back to drum kits and we'll pick another one. We'll pick something drum related. This will do. We'll just stick this in here, and then we'll add that to the basket. Okay, and then we'll actually go and look at our basket. So we've got 2 items in there, and then it's saying go to checkout. And so I think if you're adding items to the basket, if you're adding multiple items to the basket, then you need to have an account. So it's a good little exercise that we did that. If we actually remove this, we'll go to checkout again. Okay, and so yeah, it looks like if you've only got one item, you can actually make that transaction as a guest. So something we might incorporate into ours. Nice little idea there. and then we shall continue as guests. So because the whole point of this bit is just to do the entire customer journey. Then we have a checkout page where you can put in your delivery address, your postal address, and enter your payment details. It's got a thing about vouchers there. That might be quite a good little feature if we have time. We're looking to do the main basics really, and then hit a confirm and pay. And so obviously I'm not going to do that now, otherwise I'll end up with a junior drum kit that I don't really want. But confirm and pay, you also need to think about what would happen there. You'd need to send a confirmation email. You'd need to take the payment, make that transaction. So we're going to need to use a third-party payment service to do that. And then obviously you'll show an order confirmation page. So I think we've got all our steps there. We can now go away, start, we'll list down those steps, and then we can start figuring out our requirements, database tables, pages, etc. So here are those steps broken down. No need to go into minute detail at this stage. We just need to know basically what our pages are, what our tables are going to be, kind of thing. And so they are view multiple products page. So that was the page with more than one product on. Then we wanted to click on the product we like, which would take us to an individual products page where we can decide to either add the item to the basket or to buy it now. And then we want to look at the basket, review the items in the basket, then proceed to checkout, and at that stage we'll enter a delivery address, we'll enter card details, we'll complete the payment using whatever payment service we decide to use, and then on completion we want to send a confirmation email and we want to show an order confirmation page. So just having to think about that in a moment, we're going to need entity wise, we're going to need products. We're going to need things like a basket. So thinking about what we did with sessions there, because we want to be able to navigate from page to page and maybe put different items in the basket. The way that we'll record that is using the session. Okay, then we want to proceed to checkout, enter a delivery address. So we're going to need to keep a record of the order, and so attached to that will be things like delivery addresses, so we're definitely going to need like an orders table. Then we want to enter card details. We don't want to be storing card details on our own site, so this is why it's going to be in our own database. That's just messy. So what we want to do is use a third-party service which will handle all that. So when we actually go and take payment, what you tend to do is you get redirected to a page that the third-party service has created, and the user enters their details there. And then once we've done that, we've completed payment, we need to fire off a confirmation email. So we're going to need to think about creating a mailers or using some kind of PHP mailer package which already exists, and then we want to show an order confirmation page. Okay, so in the next recording what we'll do is we'll start thinking about these things and we'll decide what is the best order to create them in. Okay, so building on what we did in the last one where we did a bit of a discovery, we looked at the customer journey. I've now come up with like a very simplified, the most simple thing that we can possibly build in order to test that we have the core functionality in place. And so I've just broken it down to this, just 6 steps. And that is for one anonymous customer to be able to view a page of products. So when I say anonymous, it means they're not authenticated, they're not logged in, they're a guest customer. View a page of products, choose the product that they are interested in, click a buy it now, and so that will redirect them to a checkout page, enter some delivery details, enter some payment details, and then complete the order. And if they are to do that, then I think we can get away with just maybe 3 tables possibly, and just a page to view a page of products, a individual product page. Then when you click buy it now, that will take you to a checkout page, and we can probably enter all our delivery details in the checkout page. And it'll depend on how our third-party payment service handles things on where we enter our payment details, but I think we'll be redirected to a page which is hosted by them, enter some payment details in there, and then complete the order. By taking this minimal approach, it means that we'll cover off most of the core functionality without getting sidetracked and getting into anything too deeply complex. We'll actually have a working product where you can go and buy stuff. And so once we have that in place, then we can prioritize, okay, what are the nice to haves? How would we like to improve this product? And so having looked at these 6 steps, there's really very little we need in the way of database tables. I'm thinking maybe we definitely need a products table, we'll need an orders table, and we'll also need to perhaps have an order items table which keeps track of all of the items which relate to that order. Even though we said we're only going to order one item at a time to start off with, it's maybe a good idea to introduce that from the start, and then maybe some way of recording delivery details. But if we're saying we're just going to take a name, a phone number, and a delivery address at this early stage with our minimal product, there's no reason why we can't just put that on the orders table and then split it out later. And so I think this is the way we'll start. So we'll do it in order. The first thing we want to do is be able to view a products page, and so we'll forget about these things for now, and we'll just create a product entity and a way of displaying them all on one page. And so that's what we'll start off with in the next one. Okay, in the last couple of recordings we had a look at the customer journey, and we decided on a handful of steps which we could take in order to create a minimal product in the least number of steps. And we said that our first step was going to be to create a product entity and a products table, and we're still going to do that. What I've decided is that we're going to create an in-memory test database, and we're going to build out our product entity using our in-memory test database. So this is going to be our goal for the next couple of recordings: create an in-memory test database which starts in the same state for every test. Okay, so why do I want to do this? And there's a couple of reasons. First off, it will streamline our workflow. When we're developing using Doctrine, we're creating an entity. It means we don't have to keep updating our schema every time we make changes to that entity, and it means that we're not skipping between the browser, the database, and our editor. We just remain in our editor. Any tweaks that we make to our entity will be reflected and automatically created in our in-memory schema. So it's going to be pretty cool. If you've never seen this before, I think you'll like it. The second reason is that we want our data to be in a consistent state for each test, and so we're going to make sure that that happens also. Okay, so how do we do this? There's a couple of points. First off, I'm going to use a dedicated SQLite in-memory database which is only used in testing. Secondly, I'm going to enable our tests to read our entity metadata before the tests are run, and it will automatically create a fresh schema based on the metadata on our entities. So if I went and changed, I create a product entity, if I go and change like a field on that, I add a new field, when I go and actually run my test, the in-memory schema will actually know about that new field which I've created without me having to do anything, without me having to build up the schema or anything like that. It will just happen for us. And so it's a really quick, streamlined way to work this. Let's have a look at the steps which are going to be involved. So the first thing I'm going to do is I'm going to create, and we'll do that in this recording just so I've not just spoken to you and told you a load of stuff. We will actually write some code in this first recording. We're going to create a bootstrap-test.php file. So if we look at our bootstrap file, what this does is it basically builds up our entity manager. We say how we want the metadata to work, how we want it to be read, and we created our config. So this is the bit that's going to change. We're not going to be using MySQL, we're going to be using SQLite in memory. So user, password, all this stuff, database name, we ain't going to need that. It's going to be a much simpler configuration. So basically our file will be the same as this, except to use SQLite in memory. Okay. And then what I want to do is create a test class that can be extended by other test classes which interact with a database. So any test classes which I write, for example, if I want to create a product test which tests the creation of products or updating products, deleting products, then that will extend a database interactive test case class which has setup and teardown methods that load our schema and our entity manager. So we have the entity manager available to us in the test that our products test. Then we're going to create a tool which will, like I described, it will look at our entity metadata. So let's have a look at our user. So this is the metadata which Doctrine reads in order to create the tables and know what kind of fields to create, what values they hold, etc. And so we're going to create a tool which will look at our entity metadata and actually build the schema before each test is run. And also, so it'll be a fresh database at the beginning of each test. It'll just be the tables with no records in there. Okay, and then what we need to do is add an entry in the Composer JSON to enable the autoloader to find our test files. So what do I mean by that? Let's have a look at Composer JSON. If you remember when we added our auto-loading bit to our Composer JSON file here, what we're doing is we're mapping an app namespace to the source folder. Well, we're actually going to need to map something to the test folder, because if we're extending a particular test case with our tests in there, then we want to be able to load that test case in the first place. You'll see what I mean by that when we actually get into it. But let's not get too far ahead of ourselves. We've said that what we're going to do in this first one is just create this bootstrap -test file, which is based on our bootstrap file that we've already created. So let's do that now. Okay, here I am on the Doctrine documentation, and I'm just looking at configuration. So if you remember our connection configuration, if we go back to our bootstrap, basically we want to be able to change this so that we're using SQLite in memory. And so this is what it says about that. This is basically similar to what we're using at the moment, and then it says, oh, you can use the simpler URL form, and we're going to use something like this. If you scroll down, it tells you all about connecting using a URL, and it gives options for SQLite if we look at these. And so this is if you're actually going to use an physical SQLite database. We're not going to do that. We're going to use SQLite in the memory. So we keep scrolling down, and here is the gold. To connect to an in-memory SQLite instance, use memory as the database name. So this is the bit that we want, and we need to have a look at how this was actually set up. So it's a URL and then whatever your URL is. And so the reason why we're doing this in memory is because it will run a lot faster than if we're using a physical database. The actual setting up of building the schema and rolling it back down will be a lot quicker. Okay, so let's go over, and next to our bootstrap PHP file, we'll create a bootstrap -test. So it's just going to be a normal PHP file, -test. Okay, and then we'll go over and copy all of this stuff, and we just need to change this here, go back to the documentation, copy that, paste that in there, and then actually change the URL to what it specifies here, which is SQLite, a load of forward slashes, and then memory. What I have a habit of doing when I'm doing anything like this is to always just copy and paste it direct from the web page rather than type it myself, because there's a lot of slashes in there, a lot of colons. I'm bound to do something wrong, and why waste the time looking and debugging like little stuff like that when you could have just copied and pasted it in the first place. And so that's all we need to do. That is our bootstrap test file. So whereas previously we required the bootstrap file in our dev work. In our actual test files, what we will do is we'll require this bootstrap test file instead, and that way we're connecting to the test database rather than our development database. In the next one, we're going to work on the test case, which I told you about, which is this: create a test case class that can be extended by our test classes which interact with a database. And this will contain setup and teardown methods that can load our schema and our entity manager. So we'll do that in the next one. So we have our bootstrap test file. Now what we want to do is create a test case class that can be extended by test classes which interact with a database. Okay, and so this is going to contain the setup and teardown methods where we'll establish our entity manager and actually load our schema. I'm thinking before we actually do this, it might be best to take care of step 4 here, because if we're going to create a test case class which is going to be extended, then that's going to need to be found by the autoloader when we actually create classes which extend it. So what we'll actually do first is we'll go over to our composer.json file and create a autoload entry there which can be used for tests. Let's head over to our composer.json file, and in here we already have an autoload entry. The entry we're making here is going to be autoload dev because it's just going to be used in development for running our tests. So autoload dev, and again we're going with PSR4. Okay, and then it will be app, and then backslash, and then tests. Same again, colon, and then we're mapping to the tests folder. Okay, and so basically what we've done there is we've created a namespace mapping from app tests, which maps to our tests folder. And so all of our tests should now be discovered by autoloading. However, there's one more step. If you recall what we have to do every time we do this, when we update our autoloading, we have to do composer dump autoload and then -o, which is optimized mode. And I think that optimizes the files. I don't know totally what it does, but I always use it anyway. Okay, so all good there. We can now go and look at our next step, which is to create a test case class that can be extended by test classes which interact with the database. So we'll give this a nice descriptive name. Let's go over to our tests and see what we have in there so far. So we'll just have that one test. I'm going to create a new one, and we shall call this database dependent test case. Okay, because any tests which extend this will be database dependent tests, i.e. they'll be testing that records have been, or checking that records have been created, updated, deleted or whatever from the database. Okay, that looks good. It's added the namespace for us, which I like. And this needs to extend PHPUnit framework test case, so extends test case, and that's the one that we want. And so here what we're going to do is we're going to add a setup method and a teardown method. We'll just keep it simple for this recording. All we'll add at the moment is our entity manager, and we'll actually close the entity manager in the teardown, and then in the next recording we'll handle our schema loader, because that'll be a lot more complex than what we're doing here. So setup, so our protected function setup, and then it calls parent setup first. And then what do we want to do? Well, first off we need to require our bootstrap test file. Okay, and so I'm going to be running my tests from the project root, so it's okay to use this path here. And then we should now have an entity manager. So what I'm going to do is create a entity manager property. Okay, make a little bit of space here, I think, and we'll say this entity manager equals entity manager. And if we go to our bootstrap test file, basically what we're looking at is this. So we're requiring this file, we're requiring bootstrap test, which means we'll have an entity manager, and then we're going to use that to set an entity manager property in our setup method. And then for the teardown, all we're going to do is just remove our entity manager. So if I start typing teardown in PHP Storm, sorry if you're using something else, but I use a lot of the auto completion and stuff like that. So protected function teardown, and so similar, what we're going to do this time is actually close the entity manager, so we can say this entity manager close. Okay, I think we'll actually have some auto completion here which will help us, so I'm just going to say entity manager. Okay, and then when I try and do this again, I like to have that safety net of having auto completion, so I know that I'm getting these methods correctly. And let's go and have a look what the close method does. Okay, closes the entity manager. All entities that are currently managed by this entity manager become detached, and the entity manager may no longer be used after it is closed. So that sounds perfect for us, because that's exactly what we want to do. And then just to make sure, if I can find the right file, what we'll do is we'll say this entity manager equals null. Okay, and that should do the job. We'll no longer have an entity manager which is hanging over from between one test and the other, which could interfere with our data and our data handling. So I'm happy with this. We've made a nice start there. In the next one, what we're going to do is we're going to create a Schema Loader class, and that will be responsible for building up, reading the annotations in our entity classes and building up our schema before each test. In this one, what we need to do is work out how we're going to create our schema before each test is run. The class we need is called Schema Tool, which can be found in our vendors folder, and it's under Doctrine ORM Tools, and it's called Schema Tool. The actual method that we need is called Update Schema. Let's have a read of what this does. And so it says it updates the schema of the given classes by comparing the class metadata instances to the current database schema, and it has one mandatory argument, which is our metadata classes, and then it has a save mode which we won't need to touch. Before we go any further, let's just go and look at the constructor, and you will see that in the constructor we need to pass an entity manager interface, so we can pass in our entity manager. What I'm going to do with this is build a class around this which provides it with the metadata that it requires, and provides it with the entity manager which we obtained in the previous recording. And so I'd like to call that class something which describes pretty much what it does, and I will just call this Schema Loader, and we'll give it one static method called load, because I don't think we need to be creating an instance of anything. I think it'll only ever have one responsibility. We won't need to test its methods or anything like that. We'll know if our tests are working that it is working. So let's call this Schema Loader, and then we'll just give it one method called load. And so if you recall, we needed to pass it an entity manager, so we shall do that. And then let's actually go and create this. We'll create it in the same namespace, so in tests, new class, and we'll just call this Schema Loader. Okay, and it's given it the namespace already, so make sure if you're using a different editor or you've not got yours set up the same way as me, make sure you remember your namespace. And this isn't going to extend any test cases or anything like that, because this isn't actually a test class, it's a tool for loading the schema. And so we need a public static function. So using PHP Storm, I can just type PUBSF, hit tab, and then it will actually auto-complete that for me. And we called this method load. We said it will take an entity manager, so we'll actually use entity manager interface here. Entity manager interface. Okay, and so what did we say we needed to do? Let's go back to our schema tool and look at that update method again. So find update schema. And so we need our class metadata. We're going to need to figure out how we're going to obtain that. And then what it will do, if we just have a quick look at the code, it says it gets the update schema SQL using reading the metadata, gets a connection, and then it just goes through each of the update schema, each of the pieces of SQL, and executes it, and what that will do is actually create the tables, create the new fields, or whatever difference there is between the actual database which is comparing the metadata against. Okay, let's go back to our schema loader. We have our entity manager, so what we also need is our metadata, and the way we can obtain this is by using our entity manager. So metadata equals entity manager get, and what we need is metadata factory, and then off that we can call get all metadata. Okay, and this will get us the metadata that we need in order to pass in to our update method of our update schema method of the schema tool. Next though, we need our schema tool, so schema tool equals new schema tool. Okay, and as an argument, constructor argument, this takes the entity manager. Okay, all good so far, and then what we need to do is call update schema on the schema tool. So schema tool update schema, and then we need our metadata. Okay, perfect, and I think this should be all that we need in order for it to actually create our schema before each test. The way I'm going to test this initially is to actually create a class which extends, or create a test which extends this one, and we'll just create a test which just tests that true is true or something like that, just to make sure that what we've done so far doesn't throw any exceptions, because we've done quite a lot of work there, and we've touched on some stuff which is fairly out of our control, such as entity managers and the schema tool, which is owned by the vendor, so we don't know that we've done all of this correctly yet. So a good way to test that is to actually just create a test which extends this and just run a very simple test, and then after that we can build on that and create stuff which is more custom to what we want to try and achieve. So what I'll call this is, we're actually going to be creating products, so let's actually create a products test, and then we can use that afterwards, can't we? So okay, and this will extend our database dependent test case, and all we want to do is just run a very simple test just to make sure that we're not getting any errors, because by extending this and by running a test which extends this, it means that we know that both the setup method is going to be called, which means it's going to try and get our entity manager and create the entity manager property, and we know it's going to try and load the schema in memory, so it's going to check all of those things for us. Okay, so public function, and we'll just go test it works, and this is what I do a lot of the time before I write any of my own tests. I just write one simple test case just to make sure, or just one simple assertion just to make sure that all of my setup is actually okay. Okay, let's go and run this. So we are going to say PHP vendor bin PHPUnit, and it's tests and products. Okay, one test, one assertion. So we've got this far. That's good news. It means that the work that we've done in our database dependent test case, even though we haven't confirmed yet that we've created a schema, we know that none of this has thrown any errors. So that gives us a pretty good indication that things are working well. And it's run both the setup and the teardown, and we've not seen any exceptions. So I think we're on the right track. I think we now have enough of our test setup in place in order for us to be able to create a product entity and then test that we can actually create a product entity. So let's go ahead and do that. First off, we'll create a very simple product entity, and we'll just use some base properties. So here, having a look at an example, we'll obviously need a name for the product. Images, we'll not bother with the image path just yet, we'll come on to that later on. We'll need a price, and then I think just a description. So here we have a description, we'll have a little bit of a description in there, and obviously an ID. So just 4 pieces of data, and that'll help to just guide us and get us set up and get everything working, make sure we can create an entity and we can test that an entity can be created. Okay, let's do this. Over to our
It was in our source folder. We had a folder called entity, and we just had one entity so far, which was user. Might be able to actually borrow some of the annotations and things from this, I think so. In entity folder, let's just create a class called product. Okay, and so borrowing a bit of usage from our user entity, rather than trying to have to remember how we did all this, we needed to establish that it was an entity. We did this with annotations, by the way, and we also established what the table name was. So let's go and do that, and we'll also need to say that we're using Doctrine ORM mapping, and we'll give it an alias as ORM as well. So I'm actually just going to copy and paste this. So use Doctrine ORM mapping as ORM, and this is standard. You'll see this in the Doctrine documentation when you use Symfony. This is how most applications are set up, and then we just need to add our annotations. So we need to say that this is going to be an entity and that it is going to use a table called products in this case. So products, and then our 4 pieces of data will be, in fact, we'll give ourselves a little bit of space here. They will be ID, and then we said name, we'll have a description, we'll have a price, and I think we'll also have a created app. We'll just have that standard on all our tables. Always good to know when you're debugging stuff or when you need to check things when records have actually been created. So I'll just do this as standard on most tables which I create. And if you use the Laravel framework, I think that happens when you create models in the Laravel framework as well. So ID, name, description, price, created at. Now, if you think about how we're doing this, we're using an SQLite database for testing and we're using a MySQL database for development. However, this is where Doctrine, using a tool like Doctrine, is very clever, because by default it will automatically, to generate the IDs, it will automatically use the strategy which that vendor uses. So, for example, we said that MySQL uses an auto-incrementing primary key. For Postgres and Oracle, it will use sequences, and it'll choose whatever is the default strategy for SQLite as well. So we don't need to actually change anything. We can just use this same annotation in our product, and it will just pick the correct strategy for both SQLite and MySQL. So that's pretty cool. That's why using tools like Doctrine makes development very, very easy, rather than trying to have to do this stuff yourself and create a load of different conditionals and different logic paths if you're using different kinds of databases for testing, for development, for production, etc., etc. Okay, so name. This is going to be a string, so I'm pretty sure we have one of those here. And we'll just copy that, paste that in there. For description, this is actually going to be different. I will copy and paste it, but then I'm going to customize it. So we're not looking at string, because the description is going to be much longer. It's going to be longer than 255 characters in a lot of cases. What we need is text. Okay, price. So you probably think maybe decimal or float, but what I'm actually going to use is an integer. I'll see if there's one I can cut and paste from here. There actually isn't. In fact, here's one. So the reason I'm using integer, it just makes life simple, rather than have to deal with decimal places and floating point numbers and things like that. If you use like cents instead of using dollars, or if you use pence instead of using pounds, then you're just dealing with integers instead of floats. And I think it's just a far cleaner way to do things. Okay, created at, then we know that we've already done something like this with our user. We had a created at field there, and we can just do the exact same thing here. So it's going to be a date time, but we're also specifying that the name, the actual field name that the database will use, will be created_at, and we want to set this property every time we create a new product. So can you remember how we did that? what we did is we did it in the constructor. If you look at our user here, we just said this created at equals new date time immutable. So we can actually copy that and go and paste that as well. And then all we need to do is create our getters and setters. So I'm just going to check that all these values are correct first. That looks good, that looks fine. Integer, okay, so I think we're good, and I can actually do this automatically rather than do them all individually. If I hit Control and Enter in PHP Storm, it'll say getters and setters. Okay, I'm just going to choose them all and then delete a couple of them. So I don't need a set created at, because that will happen in my constructor every time I create a new product instance. And then also set ID. I won't need one of those. I won't need to manually set an ID, because that is going to be done using auto incrementing IDs by my database. And so I think we're good there. I'll just have a quick run down, get name, set name, get description, set description. Okay, happy with all of that. Now let's go back to our test and test that we can actually create a product in our in-memory database. So we don't need this test anymore, and I'm just going to change it to a new one, a product. A product can be created, and then we'll remove this and we'll just add our three stages. Okay, setup, do something, make assertions. What's going to be our setup? Let's go back and have a look at this record here. And so we're going to need a name and a description. So I'm going to put these in variables, because it might be something that I'll need to make assertions against. So I'm just going to copy this, go back and just say name equals. Okay, so we have a name for our product, and then go down to the description, and we don't need to copy the whole description, but we'll just take enough to test against. We'll do something that'll do us, and then we'll go and have a description variable. Okay, good, happy with that. And then what we want to do is actually create a new product object. So product equals new product, and then product, we shall set name to name, set a description to description, and we'll set a price, and we'll just go with how much do these things cost? I'll not tell the wife. 944. Okay, and so we need to include the pence after it, or the cents, so this will be 94400. 94400. And then in the do something, this is where we're going to do our persist and our flush. So if you recalled, I think it was in our user script, let's see if we have our create user. What we did was we call entity manager persist. This brings the entity which you've just created, or the object which you've just created, under the entity manager's control. Nothing gets saved to the database. Database doesn't get altered at this time. It just gets added to what is in memory for the entity manager, so it knows what it has, what it's going to need to do, and then when you call flush, that's when it actually creates all the actions. So it could be doing multiple things. You could have multiple entities which you've passed to the entity manager, and it could be updating some, deleting others, creating others, and it all happens in one go when you call flush. And Doctrine will figure out the most optimized way to handle all of that SQL. Okay, so that's what we're going to do here. And we need our entity manager. So this entity manager persist, and we're going to persist the product. And then we need to say this entity manager flush. Okay, we don't need to pass it anything there. And then we're going to make assertions. So what would be a good thing to assert? Eventually what I'd like to have is a custom test assertion which asserts that I can check in the database for a product or any kind of entity really with the properties or the values for the properties I provided. So for example, I want to test that I can find that there is a product in the database with this name, and with this description. And so I'll probably create, or I will create, a custom assertion to do that. But initially we don't have the luxury of being able to do that, so we just want to quickly test something which will give us a good feeling that it is working. So what I'm going to do is test that the product has been given an ID, because at the moment it won't actually have an ID until it has been written to the database. So I can say this assert same, and we're looking at the value 1 because we're creating a new database each time. Then we know that the first record that gets inserted in there will have an ID of 1, and then we're going to use a product get ID. So I'm asserting that our product has an ID of 1. Let's actually go and run this. Okay, 1 test, 1 assertion. This is good. What we also need to check is that the schema is being created, is being torn down between each test. And so a good way to do that is to actually take this test here, just copy it, paste it with a new name, and we'll just call this duplicate. Make sure that it is a test. Okay, so let's just be clear on what I'm doing here. We're going to run both the tests because, as you can see, I was running all of the tests in products tests, so both these tests should run. And to make sure that we are actually tearing down and starting with a fresh database in between each test, then what that means is the ID for our product will be 1 here, but also we're starting with a fresh database in our second test, and it means that the product will have an ID of 1 here. If we weren't starting with a fresh database, it would auto increment, and it means that then we'd have a incremented value here, so we'd end up with 2. Okay, so let's go and run this, hope for the best. 2 tests, 2 assertions. I'm happy with that. Let's now actually go over to our physical database using Table Plus. Have a look at that. Make sure no products table has been created and no products records have been created in that. So here's my BTB project. I've only got 1 table, which is the users table, and so I'm pretty confident now that what we've created here is actually creating our schema in memory before it runs each test, and that it is actually persisting records to that database. So we have a nice little test set up here, and in the next one what we'll do is we'll create custom assertions where we can actually look in the database after we've run all these steps, after we've persisted, look in the database and see, do we have a product in the database with this description and with this name, and then we'll know that we definitely have what we hope we have. Now we know that these 2 tests are working okay and that they are creating independent new records which start out with a ID of 1, so we know that the database is starting from fresh on each test. So I don't think we need this second one here. What we're going to do is concentrate on the first one and actually improve it, because this isn't ideal testing for an ID. What we'd like to do is pass it a little bit more knowledge and ask it to do a bit of a more rigorous test. And so what I'd like to do, and this is sort of taking inspiration from Laravel. So I've not used Laravel for quite some time. However, I do remember it had very good testing, and you were able to test that a certain model was in the database if you passed it the name of the model and the name of the attributes. And so we're going to do something similar here. And so I'd like to have a test assertion which is called assert database has. So assert database has, and then this will take 2 arguments. The first one will be the entity, so in our case it will be the product, and then it will take an array of attributes that you want to test against. So for example, we want to test that the name is name. Okay, and then what else do we have? We have a description, and so equals description. And so you pass it an array of key value pairs. It looks in the database to see, do we have a record in the products table which has these attributes here. And so what we need to do is go and actually create this method somewhere. So where would be a good place to put this? Our products test is specific for products. However, it extends database dependent test, and we're making an assertion against a database, so that is the ideal candidate to put something like this. So let's just copy the name and let's go over to this, and we can just drop in a new assertion underneath our setup and our teardown. So public function assert database has, and this will need to be an entity as the first argument, so we'll just say entity, and that will actually be a string because we're going to pass it in string format, and then the next argument will be an array of attributes. And so for this first assertion, all I'm going to do, just to make sure that we are hitting this method and that it's working, I'm just going to this assert true, and obviously this test will pass, but then we'll know that we are hitting this assert database has method here. Okay, so let's go and run this. Back over to products test. I'll just make this a little bit bigger. PHP vendor, in fact I can do vendor bin PHPUnit like that, and then we'll say tests, and it is in products test. Okay, so can you see what error we're getting here? Actually, it's saying argument 1, we said that we were going to make argument 1 a string, but what we've actually done is we've gone and passed in the product. So what we want to be doing is we'll just read this message: type error app blah blah blah, assert database has argument 1 entity must be of type string. And so the way that we do a string is product : class, and so then it will actually look for a string. Let's go and run this again. Okay, so one test, one assertion. We can now start driving out the actual real functionality that we want this assertion to perform. The way we can do this is using a repository, and so each entity, each Doctrine entity has an associated repository by default. You can create your own custom repository for the entity, but we're just going to use the default one which is generated when we create the entity. And so what we're going to do is we're going to get the repository for the entity we're after, which is the product entity, and then in that we're going to use a method on the repository called findOneBy, and that will take an array of attributes exactly the same as what we are passing in here. The string entity is what we will pass into the find repository method, and that will find us the repository for the particular entity that we're looking for. Anyway, the best way to explain this is to actually demonstrate it. So we're going to say result, because this is the result we're expecting to get back, equals this entity manager, and we want repository, so get repository, and as you can see it takes an entity name in string format. So entity, and then now we have our repository, and off that we can call the method findOneBy, and if you look, this takes an array of criteria. So I think that would actually be a better argument name. Let's call this criteria, and then everything is all matching up. Obviously we can call it whatever we want as long as we're passing in an array of key value pairs that we are looking for, but let's just stick to what how the API is documented. So result equals this entity manager get repository findOneBy, and so what it will return, it will either return us a product entity, okay, or it will return us null. So we're either going to have a product or null, which means we can cast that to a boolean. If we find a product entity and we cast that to a boolean, it will be true. If it comes back with null and we cast that to a boolean, then it will be false. So all we need to do really is just this assert true bool, so we're casting the result to a boolean, and we're just going to say result. And so if it finds a record in the database, this assertion will pass. If it doesn't find a record in the database, then this assertion will fail. Let's go and run the test again and see how we get on. Okay, one test, one assertion. So, quick sanity check to make sure that it's not passing by accident, because these things do happen. Let's go over to our products test and actually change the description to something which is different than what we've actually persisted in the database. And this, I think, will be our real, when we know for sure that what we have created is really working. So description, foobar. Okay, and hopefully this will fail. Okay, that's brilliant. That's excellent news. That means that we have definitely created a record in the database with these credentials, and so I'm well happy with that. What I'm not so happy with is when it does fail, our only message is failed asserting that false is true. What I'd really like to see is a message which says why it's failed. For example, we couldn't find a record in the database where name equals this and description equals this, and then you've got a far more descriptive message. It just helps debugging when you're running a lot of tests at once, and so we'll work on that one in the next one. Now, when you write assertions using PHPUnit, you can actually pass a second argument to the assertions, and that is a failure message, a meaningful failure message to let the user know a bit more detail on why something has failed. And so that's what we want to do in this one. I want to pass a second argument to this, which will be a failure message. But first, we need to actually come up with a message. So what I'd like to do is have something a bit like this. So if it fails, it couldn't find a product record in the database, it will say a product record could not be found with the following attributes, and then it will display the attributes which were actually passed into the test, and so it'll give us a good idea of why it's failed and that record definitely isn't in the database. So that could be quite tricky, because at the moment we just have an array of key value pairs, so there's going to need to be a little bit of manipulation here to get the string looking the way we want it. And so you might think, well, isn't this a bit overkill? And in some situations it might be, but what we're building here is we're not just going straight to coming up with an e-commerce solution. I'm showing you how to build a system which can be maintained and extended and which will last years and which other developers will actually enjoy working on, rather than just having something which has been cobbled together. It's just one solution which solves one problem. When you build systems, you can solve multiple problems, and so that's what our focus is really on this one. So let's think about how we can actually create this failure message. We're going to have to sort of loop over our array, take each part and convert the key into something like this. Key equals value, and then each set is going to be separated by commas. Okay, and so I think what we'll do, because I want to also have an assert database not has for when, for example, when you want to check that a record has been deleted, I'd like to have an assert database not has. So rather than writing the logic in this assertion for what I want to achieve, I'm going to actually create a separate function or a separate method which can be used in both the assert database has and the assert database not has assertions. So let's do that now. Now we want to convert our key values array into a key values string. So for lack of a better name, I think I'm just going to call this as key values string, and obviously it's going to take an array which will be the criteria, and I'm thinking maybe we can specify the separator. So we could allow for separators which look like colons or separators which look like equals, and we can let the user decide how they want to, or the client code writer decide how they want to display this. So I think it might be good to have a separator variable equals, And then our default is we'll have a space, an equal sign and a space. I think that'll look fairly nice and neat. The way I've decided to do this is I'm going to use array map. So what array map will do, it will loop over the array and it will perform a specific piece of functionality on each row of the array, each item in the array. And that functionality that we want is to get the keys and the values and put the keys on one side of this and the values on the other. And so let's give this a go. Okay, so array map will actually return us back a new array. So what we're going to do is we'll call this mapped attributes equals array map. And let's actually go and look at this function and see how it works. Applies the callback to the elements of the given arrays. So notice there plural arrays, and I think that is likely to be our case. So the first argument is the callback, so we'll pass a function there, and then we're going to need to glue keys and values together. So I'm thinking we'll have an array containing the keys and an array containing the values, and we'll use both of those parts inside the callback to glue them together. Let's go and give this a go. It'll make more sense once we try this. So we've said that the first argument is the callback, so function. And what we want to do is actually perform this functionality using keys and values. So we'll say key and we'll say value. Okay, and then we have our callback function, and then our next arguments are the arrays. So we're going to have the keys array and the values array. How do we get the keys array? So we can use the array keys function, which will return you all the keys, an array of all the keys from an array, and that will be criteria, and then we just want the values. So for that one we can just use criteria and it will use the values for that. Okay, and then inside of our callback, so if you look where we are here, we're inside of the curly braces, inside of the callback function. Thinking about this, we have to make our separator available within our callback, and so the way we do that is we say use and then in parentheses separator, because at the moment it wouldn't have been available to us, so we wouldn't have been able to use it within the callback, but we made that possible by saying use separator before the opening curly brace. Okay, and then what we need to do is return key concatenated with separator concatenated with value. Okay, and so what we should get now is each row of the array, of the original criteria array, will be worked upon by this callback here, and then it will return us a new array of mapped attributes, which will be the key of each array, appended with the equal sign and then appended with the value. So let's actually go and dump this out just to make sure that we are getting what we hope we are getting, and if we run the test we should see this. In fact, what we need to do is actually call the method inside this assert database has. So this has key value string, and then we'll pass entity. In fact, we don't want entity, we want criteria. Okay, run the test. Okay, this is great. So we have name equals, and then it gives the description, and description equals, and then foobar, because that is what we were using in the test last time we ran it. If you see here, description is foobar. So this is pretty good. Now it should be fairly straightforward to convert this from an array to a string separated by commas. We can simply use implode. So what we can do it only one line, return implode, and then the glue will be a comma and a space, and then the array will be our mapped attributes. And let's go and grab this value, so we'll just call this key values string, and then we'll dump this out. So dump key value string, and let's see what this looks like. Name equals blah blah blah, comma, description equals foobar. Okay, great. So all we need to do now is just create our failure message. If we go back to where I'd created or started to create one, we can now say failure message equals, paste that in there, and it's not a product record, we need to use the entity name. So we'll change this to double quotes. A entity record could not be found with the following attributes, and then in here we just need to use our key value string. Okay, and then we'll dump it out. So this is pretty much how I work. I just do a little bit, dump it out each step of the way, and then you know if something hasn't worked, you know exactly where it hasn't really worked. Okay, so a app entity product record could not be found with the following attributes. Name equals blah 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 blah, description equals foobar. So this is a perfect error message really, and we can now use this in our assertion. And so as you can see, we've already got failure message in there. Let's go and run this and see how we get on. Okay, so we have a failed test. A app entity product could not be found with the following attributes. Name equals this, description equals this, and then there's the standard message which came with the assertion, but now we have something which is much more customized, much more understandable, and we'll be able to understand exactly what the problem is. In the next one, what we'll do is we'll actually go and create another assertion, a sister assertion to go with this one, which will be fairly similar, but it'll have its own error message because this time we are asserting that the database doesn't have, and we'll call that assert database not has. I'll see you in that one. Okay, so in this one we're going to create a new assertion to assert that a database doesn't have a particular record. What I'm going to do before I do that is actually go back to our products test, tidy this up, return it to a passing test. So this should work now. Let's go and run this. Okay, and then in order to assert that a database doesn't have a particular record, what we'll do is we'll just copy this and we'll say assert database not has, and then obviously we need to give it some attributes which won't be found in the database for a product class. So again, we'll just go with foobar, and so now we should see one passing assertion and one failing assertion. So one test, two assertions, only one of them which passes. Okay, so our error is actually that we are making a call to an undefined method, assert database not has, because obviously we haven't created that yet. Let's go and do that now. So over to our database dependent test case. And so it's going to be very similar. The entity and the criteria are both going to be the same. Let's paste that in there. So a lot of this will look like duplication, but it wouldn't really be worth trying to do some kind of refactoring, because if you think of something called the rule of three, if we make the same repetition twice, then okay, we can live with that, because you're not saving anything by having a refactoring. You'll still end up with the same amount of code. However, if you end up where you're duplicating something for a third time, then that's when you should consider refactoring, because then you really do have true duplication in your code. So, but a lot of this, some of it's going to be the same, some of it is obviously going to be different. So we'll paste that in there. This will be the same. Entity manager, get repository. We're still looking for the same. Entity. We still want to convert our criteria into the key value string. The failure message, however, will be different. What we're going to say here is a record was found with the following attributes. So we'll put that in capitals just to make it obvious that it shouldn't have been found. And then instead of asserting true here, what we're going to do is actually assert false. Okay, and so let's go and run our tests again and see what we're up to now. 1 test, 2 assertions. So let's go over to the test and see why this passed. Assert database has, yes, there is a record in the database with that name and that description. Assert database not has, no, there is not a record in the database with a description or a product in the database with that name and with a description of foobar. I'm happy with how this is working. I can test that a record can be found in the database, and I can also make an assertion that a record can't be found in a database, and that'll come in handy when we actually decide that we want to remove records from the database. And also, if you actually look at these assertions, they can be used with any entity. They're not just for products. This is nice and loose. You can pass in any entity in here. And so we have a couple of nice reusable test methods there that we can use throughout our application for everything that we develop going forward from here. Okay, so now that we have a nice little test setup there, we have a test database which will recreate itself before each test. Let's sort of mentally switch back to dev mode now, because we need to actually add our products table to our dev database, our MySQL dev database, because in here we still only have the one table which is for users. The way we're going to do this is we're going to use a command line command from Doctrine, which will do the same as what we did for our test database, where it will read the annotations, look at the metadata in our entities, and use that to actually build up the database. And so the command is this. If we look at the Doctrine documentation here, if you actually read what it says here, it's using the Schema tool. So it's using the same tool as what we used in our test, in our Schema Loader that we created. And so when we go and run this, like I say, it will look at the entities, look at their annotations. In fact, let's go and look at a product here. And so we're expecting it to create a table with a products table with an ID, with a name, with a description, with a price, and with a created at field, and it will be created _at. So let's go and actually test that theory. If we paste the command in here, now we know that it's going to update the dev database, because if you remember when we did this for users, if we actually go and have a look at the little script that we wrote, which was this CLI config, as you can see, require one's bootstrap, and the bootstrap file, the original bootstrap file, not the test bootstrap file, uses MySQL, and it uses our BTB project database, which is hosted at localhost. And so, as you can see, we're using the BTB project database. So I'm pretty hopeful that this should work. Let's go and run this now. Okay, one query executed, and so that will be the query to create the products table, I should imagine. Database schema updated successfully. So let's go over to Table Plus or whatever database tool you are using, and we'll give this a refresh. Okay, great stuff. So I can now see we've got a products table, and we have an ID, a name, a description, a price, and a created at. So let's not leave it there. Let's actually add a product to our database. Okay, so insert into products, and the fields that we're going to insert will be name, description, price, and created at, and then it will be values, and then so we need to go and get, we'll use the ones that we used in our test. Let's go and copy from there. So products test, and we had a name and a description, so we'll use the same ones. Name and created at, we can just use the current timestamp. Okay, let's maybe tidy this up a bit on each on their own lines. So hit enter there, and I'll just tab them in. And then I can just go and run this, and run current is command and enter. So command enter. One row affected. Let's go over and have a look at our products. Refresh. Okay, so we have an ID, we have a name, we have a description, price, and created at. Let's now take this one step further. We have the data that we need. Let's go and create a product page which will dynamically receive this data and populate the page with the name, description and the price, and we'll add a Buy It Now button also.
Okay, we now have a products table in our dev database and we've created a product in there. Let's now go ahead and create a page where we can go and look at a single product and then click a button to buy it now. And so what I'm going to do is create a public folder in the project root. So if I close this, we're in the project root and this will be in public. And then I think a logical way to go with this is to go inside of that public folder and create a products folder. Just to keep our site segregated and logically separated really, and then inside of there, in order to view a single product, we'll have a view page. So we'll just call it's just a normal PHP file, not a class or anything, and we're just going to call it view.php. Okay, and so now we actually need to drop some HTML in here in order to be able to view a product, and then what we'll do is we'll plug in some PHP to dynamically grab our one and only record from the database. So the way I'm going to do this is I'm going to go over to my trusty Bootstrap, get Bootstrap 5. My goal here is really just to get something on the page, something very basic where I can check that it is dynamically loading the name, price, description, etc., and that we can click a Buy It Now button, which will take us to a checkout. So this isn't going to be anything very extravagant. However, like I said at the beginning, I am planning on open sourcing this to you guys, and so I will accept pull requests. If someone can come up with a better design than what I come up with here, then I'll pull it into the project. Okay, so this one is called Sticky Footer Navbar. I think I have used this one before, and it serves the purpose really. So then I right click and go to page source, and I'm just going to grab all of this, copy it, go over to my view file, and then paste it in there. And so we can actually go and look at this now. So just get rid of this space here. Let's just check our work as we go along. So I'll move into the public folder, and I'm just going to start up a PHP built-in server. So PHP s localhost, and then we'll click on this, and then we're looking for products, and then view.php. Okay, and so you'll notice the styling is a bit out, because if we actually look at the source code here, we need to get this CSS. So if we go back to the Bootstrap front page, home page, and just down here we have the CSS. So I'll copy that, and then I'll go back to my project, and then in the head I'll just remove this. And so this should look a bit better. Okay, so I'm not sure if it's exactly the same. There might be another bit which I need to grab. I'll grab this styling here. Yep. And there's another sticky footer navbar CSS which I need to grab. So you just have to bear with me while I work through this stuff. Okay, and I'll click on this sticky footer navbar CSS, and there's just one style there, so I'll grab that. And I think this will add the padding by the looks of it, so that should give us that little bit of spacing at the top. Let's go and have a look at this again. Okay, great stuff. So now it's exactly the same as the example on the Bootstrap site. And what I tend to do now is just start removing stuff, because I don't actually need most of this. So I'm just going to have my own little logo there. I'll get rid of all these links, get rid of everything that I don't need, or comment it out, and if I need it again later, then I'll put it back in there. So down to the header, and what I'm going to do is actually cut the entire header and just have it as a site header template. So grab all of this, cut that, and then in public I shall create an includes folder, includes and then I shall call this site header. So site hyphen header.php, and then I'll paste that in there. And in fact what I wanted to do was actually include the head as well. So all the way down from the very top to the end of the head section. So we'll cut that, and then we'll go back over to site header up to the top, and we'll paste that in there. And then what I need to do is go back to the view file, open some PHP tags, and include my site header. So include and then it is one and it is in includes site header. So hopefully we should run this and it should look exactly the same still. Okay, so far so good. Now what I want to do is get my bootstrap file, so require once, and this time we are going up 2 steps, so 2, and then that is in. Go and try this again. Okay, nothing broke there, so I'm guessing that that was correct. And then what we'll do here is we shall just dump out our entity manager just to make sure, just to give us that sanity check that we are actually pulling in our bootstrap file and we have access to the entity manager, because we will need that to get our product. So I'm going to say dd, and we should have auto loading, because if you remember in our bootstrap file, one of the first things we added was our auto loader. Okay, so that means I can use my Symfony var dumper, the die dump function, and we're just going to die and dump the entity manager. Okay, back to the browser, give this a refresh. Okay, great stuff. So there you can see our entity manager. We can dump out PHP stuff into our browser. So far so good. Now what we want to do is actually replace the heading with the name, and another thing we'll actually do is in our site header. Okay, so here's the title. We want to replace the title with the name as well. So the first thing we shall do is we shall get our product from the database. So I want to have a bit of auto completion to make sure I'm calling the right methods. If you're not familiar with Doctrine, or not too familiar with Doctrine, I recommend that you do this also. So we'll say em equals entity manager, and what that does, it gives us the ability to do this with our code comments. Var, and we're saying that that will be an instance of entity manager, and so I'll just get rid of the squiggly lines, disable inspection. And so now we'll get auto completion. Anytime we use em, we can get some auto completion from PHP Storm. So em get repository, and the repository is product class, and then off that we want to do find one by. In fact, we can use find ID. We know that it has an ID of 1. If we look at our product that we put in there, it has an ID of 1, so we don't need to use find one by here. We can just say find, and that takes the ID. Okay, and so that means that we should have a product. Just excuse me, I don't have any error handling in this just yet. I'm just staying happy path for the moment. We'll put some error handling in later, but at the moment this is just rapid development, getting our product, dropping it in the page, showing the name, showing the description, etc., and then we can focus on error handling later on. Okay, so product, and then I think we're pretty good here. What we'll do is we'll say title equals product get. In fact, we'll also have some auto completion here, get name, and then we can go to our site header, and in here we can just echo out the title. Okay, because we've made the title available here, we're going to say the title is actually the product name, which means that when we include our site header, the title can be used in that file. And then what we want to do is replace some of these bits. So I can actually just borrow that. So in there, we shall say product get name. For the description, we'll just remove all of this stuff. We don't need any of that. And we will say product get description. We also want to display the price before the product name. So what we will do here is we shall say span style equals color, and we'll go with red. $, and then this will contain the price. So we'll drop the price in there. Product get price. Okay, so this is becoming a bit of a mess. It might be a bit hard for you to read, but basically what we've done is we are echoing out the price and then the product name in the header, and then after that we are echoing out the description. Okay, let's go and see if this has worked and what it looks like. Okay, so this looks pretty good, except for the fact that the $ also needs to be in red, and this drum kit does not cost $94,400. Get this number into dollars, I need to divide it by 100, and we'll also use some number formatting to display the decimal places correctly. So I'm going to use PHP's built-in number format function, and what this does is it formats numbers, believe it or not. We're going to format it to do decimal places, but before we do that we need to divide the price by 100, and then it's a comma, and then the second argument is a number of decimal places. Let's check this out. Okay, that's looking better. We now need to move our $. We had it in the wrong place. It needs to go inside of the span if we want that to be red. So just before we print out the price, we've moved it to that location. We're slowly getting there. Then what I want to do is, I don't want the search box, I don't want this, I don't think, for the time being. So we'll not get rid of it completely, I'll just comment it out. And also these links, home link disabled, so home link disabled are all part of this UL that we see here. Let's do the same there, we'll just comment it out for now. And then if we want to put it back in there later on, we can always do that. Let's see what this looks like. Okay, good. The final step we need to do is we need to add our Buy It Now button here. So over in our view.php file, just underneath the description here, we're just going to add an A tag. So the href will be products, and then what we're going to have is just a page called single product checkout, because at the moment all we're doing is we're allowing someone to buy just a single product or a quantity of just that product. When we actually get to adding stuff to the basket, then we want to have a different checkout page than this one. It's going to work completely differently. So this is just to get this minimal product going. So in the products folder, I'm going to create a file called single product checkout. Okay, and in here we shall just echo, for the time being, just some placeholder text, check out page. Okay, and then this will be, just copy that, single product checkout PHP, and we shall say ID equals, and then we will echo out the product ID. So product get ID, and what we want to do is make sure that this is styled as a button, so it's class equals btn, and then btn, and we'll say primary, which should give us a blue button, and we'll just say the text will be buy it now. Let's go back and have a look at this. Okay, so we have a Buy It Now button. When we click on this, it takes us to our products single product checkout page. Okay, so we'll leave it there for that one. As you can see, when you start getting into front end stuff, it can take a lot longer than actually doing the back end stuff. In the next one, what we're going to do is we're going to actually remove this hard coding, because we've hard coded the value 1 here. We're going to get this dynamically using query parameters, and then we'll have a look at what consists of an order and how an order relates to a product. So I'll see you in that one. I decided to make just a very short recording to get rid of this hard coding that we did here, because I don't want to mix doing that with the lesson on creating an order and working on the relationship between order and products. So what we'll do here is, the way I want it to work is to grab an ID query parameter, and then that will be used to query for the product, doing it that way. And so we will say ID equals, and then it will be get. And this is how we grab a query parameter, and we'll just call this product ID. Okay, and so then we're, instead of hard coding in the value 1, we're just going to pass in the product ID. So let's actually go over and start up our server. You've probably got yours still running if you've carried on straight from the last lesson, but I've had a break since then. So localhost 8000, and then where do we want to go? We want to go to view PHP and then ID equals 1, because we know we have the product with one ID of 1 in the database. Okay, and we actually got that wrong, don't we? It's products view, so you can tell it's been a couple of days since I last recorded. Products Alright, good. So we're back to where we want to be, and this is much better. So instead of hard coding the value 1 in there, we're actually using a query parameter. So I'm going to keep it this simple for now. I'm not going to do any more. If later in the course we do decide to get into routing and stuff like that, it means that if I put a lot of error handling and stuff in here now, it's just work which would end up getting reworked. So I'm going to leave it the way it is for now until I've had a proper think of how we're going to handle this as a whole later on. Okay, we can now move on to working on orders and the relationship between orders and products. Okay, let's now have a think about what an order looks like and how an order relates to a product. So we'll take it one step at a time. First, let's look at orders. I've created a little file here just so you've got a visual to look at as I talk through this. So we're going to need an order entity. We'll need an orders table in the database. And I've gone through and I've thought about the fields which would be needed for our minimal product that we're coming up with. And so I'm going to keep delivery address, delivery name and delivery details with the order for the time being, because like I say, we're just creating a minimal product and I'm happy for it to stay there, because we're not going to have user records for our minimal product. It's going to be where you can order as a guest, and so we can add delivery details to the order, I think, doing it that way. Okay, so obviously we're going to need an ID, that's a given. Then we're going to need a delivery address. So I'm not going to split it down, I'm just going to have one big string or one big text, and that will take care of the whole delivery address, zip code, postcode, whatever you want to call it. Delivery name, so this will be the person who it's being delivered to, obviously. I've thought about something like delivery status, you know, is it dispatched, is the order delivered, whatever. And like I say, we're just looking at a minimal product, and what were our minimal requirements? We said we wanted to place an order, visit a page, hit a Buy It Now button. That will take us to a checkout page and complete an order, pay for it, and that's all we wanted to do. So and that's all we are going to do for the time being. When we go on to building out the more larger e-commerce solution that we're going to do after we've created this minimal product and got this minimal product through the door, then we can look at things like order statuses and stuff like that. But for now, it doesn't actually fit the needs of our minimal product, so let's just leave it out. Don't get sidetracked by things like this. It's very easy, and you see developers do it all the time. Think, oh, this would be a nice to have. Just stick to the script. You know, we've decided what our minimal product's going to be. Stick to the script. Created at, and that's just by default. I'm going to have created at on all of our tables because I think it's just the best way to go. It makes it easier to go and just quickly check things if you have anomalies, data anomalies and stuff like that. And then these sort of fall into the same category as what I'd say status do. They're nice to have. They can form part of our larger e-commerce solution when we move on to that. But for our minimal product, we don't need to be dealing with discounts or saying dispatched at. We'll just leave those out for now. And so that brings us on to the relationship between an order and a product. So you'd think that probably the most common way of doing this would be to have like a join table and a many-to-many relationship and model it that way. And so we are going to do something similar, but not quite. The many-to-many relationship and the join table, what you would do is you would have the products table and you've got the orders table, and then you'd have a join table which has an order ID and a product ID and a many-to-many relationship between the two. However, what we're going to do is actually have a order products table, which will have a many-to-one relationship with orders and also a many-to-one relationship with products. And that just gives us, by actually modeling this and having its own entity, what it does is it gives us a bit more flexibility. We can add more data to it, because when you create an order, you want to know what price was paid for that item, because it might not be the same price all the time. You might have discounts and things like that. You want to know when it was created at, because you might have an order which is created at some point, and then items might actually get added to the order at a later date or at a later time. And so you want to really be able to track that. One other consideration I thought about, in fact, we'll go through these one by one. So we're going to need a order ID, which will reference the orders table. We'll have a product ID, which reference the products table. In fact, this will have its own ID. And so, this will have its own ID because it's its own entity. We'll need to know the price that was paid. Now, this is interesting. I thought about quantity. For example, if you want to have 2 of the same products added to the order. However, the thing with having quantity and just recording all of the products, if you have 3 of the same product on an order, is that if you start removing products and things like that, then it can get messy. What I prefer to do is just, if you have 3 certain products, 3 of the same products related to an order, just create 3 records in the order product table. If you want to do stuff like buy one, get one half price, then it's much easier to record how much has been paid for each item when you do stuff like that. And so I think that will do us. Remove that. Yes, later on we will look at removing items from orders, but for now let's just keep it simple, and we'll have those 1, 2, 3, 4, 5 items on our order product entity. Okay, in the next one what we'll do is we'll go and have a nice gentle start. We'll go and create an order entity, and we'll test that an order can be created, an order can be updated, and an order can be deleted. I'll see you in that one. Now let's create an order entity. The way I'm going to do this is I'm just going to drive it out with the test. So a bit more test-driven development. We'll create an orders test, and we'll just create one simple test first to test that an order can be created. And so in our test folder here, let's just create a new one. So PHP class, and this will be called orders test. Okay, and so this is going to extend our database dependent test case, because it's going to be an entity. We're going to have an orders table sitting behind this entity. So extends database dependent test case, that is the one. And let's create a test. So test, and let's see if there's anything that we can cut and paste from our products test, because we've done something very similar already, haven't we? So we'll go to products test. Product can be created. Okay, so always saves you a bit of time if you've got something that you can go and just paste in, customize and work with. Okay, so obviously this is going to be different. What did we say that our fields are going to be? Let's have a look at our requirements. and we said we're going to have an ID, a delivery address, a delivery name. The created at, this will happen automatically the same way as it does with our products. When a new product is created, then it automatically gets populated with a created at. So the only two fields we're looking at physically creating or physically adding are the delivery address and the delivery name. So let's go and change these to, we'll start with delivery name. Delivery name, who can we deliver a drum kit to? Ringo Starr, not Rongo Starr, Ringo Starr. And this one will be delivery address. Okay, and so we'll just call this 44 Penny Lane. Okay, 44 Penny Lane, Liverpool. And then instead of having products, we're going to have orders. So we'll delete all of this actually. So order equals new order. And then we'll have a method called set delivery name. Order set delivery name. And that will be set to our delivery name. And then order set delivery address. And we'll set that to our delivery address. Okay, and then we're going to persist and flush. And then we need to make assertions. So what we're going to do is we're just going to make an assertion that database has an order. Okay, so obviously when I run this now, in fact, it needs to be called an order. An order can be created. So an order can be created in our setup. We have a delivery name and a delivery address, and then we're just going to new up an order, set the delivery name, set the delivery address, persist and flush, and then we're going to just check and see if our record has actually been created in the database. When I run this now, obviously we're expecting this to fail, but that's basically how test-driven development works. You do a bit of code, you'll get a red, and then you go and get your test passing, and then do any refactoring which you need to do. And so I'll just make this a little bit bigger. Vendor bin PHPUnit. Okay, error. Class app tests order cannot be found. So we need to go and create an order entity. So down in source, and then we have an entity folder here. We'll just create a class and we'll call it order. And then back to our test, and this time we shall change this order for our order entity. Okay, and then run the test again. And this time it's saying, so we've got one step further because it's not complaining that we don't have an order anymore. This time it's saying call to undefined method app entity order set delivery name. So we don't actually have a delivery name. So let's actually go out and add our properties, add our setters and getters and setters, and then we'll have a full order entity. So our properties were, okay, so there's our properties: ID, delivery name, delivery address, and created at. Let's now go and make this an entity, and so again we can go over to our product and have a look at that and borrow some of the stuff from there. So we need this code here which declares it as an entity. First thing we're going to need to do though is actually get our mapping. So use and if I start typing mapping, this is what I'm looking for: Doctrine ORM mapping, and then we give it an alias as ORM, which is pretty standard, and that's how it's commonly done. Then we can paste in our entity code here, or our entity annotation, to say that treat this class as an entity, but the table is going to be called orders, and then ID. So what I'll typically do is I will always try and copy things like ID from somewhere else, because it's very easy to get it wrong. There's quite a lot to remember there, but like I explained when we create the product, here we're just saying it's going to be an ID. This is going to be the identifier, the primary key for this table. It's going to be of type integer, and it's going to be an automatically generated value. And so because we're attached, or because we're using MySQL, it will be an auto incrementing ID. Delivery name, so this will be a string, so this doesn't need to be too great, so I'll copy this. At ORM column type equals string. Delivery address, this has the potential to be a bit longer than 255 characters, so like we did for the product description, we're going to use text this time. Paste that on there, and then created at will be the same here. So we're going to say this will be a datetime interface. And if you recall how we made sure that a created at value was created every time we created a new order, what we did was this, so construct, and then in here we say this created at equals new, we'll use datetime immutable, okay, and that will do us. Okay, so what we need to do now is actually go and create our getters and setters, because we want to have these methods here available to us. Set delivery name, set delivery address. Okay, so in PHP Storm I can hit Control and Enter, and this will bring up a little generator menu, and if I go down to getters and setters, I'll choose all of these, and then I'm just going to clean it up a bit. So it's added a set created at. I know that this is going to be done every time I create a new order anyway, using the constructor, so I can get rid of that. And the other one which I can get rid of is set ID. The ID is going to be set by MySQL when we create the records in the database. And so let's just have a slow scroll through here so you can see all of the code. So there are, so I'm using the mapping, and then here's my annotations to say that this is an entity, and then we have an ID, delivery name which is a string, delivery address type text, created at type date time, and the name of the field in the database will be created at. And then we got get ID, get delivery name, set delivery name, which is one of the things that we're using in our test, get delivery address, set delivery address, again we're using that in our test, and then get created at. So we can now go back to our test. All the squiggly lines and everything has disappeared, so I'm quite hopeful that we may even get a passing test here. Let's give it a go. And indeed we do. So one test, one assertion, we've set a delivery name, we've set a delivery address, and obviously the other fields get set automatically. So what I did there was a bit of a hybrid approach. If you were going purely test-driven development, then what you would do is you go back and you'd add each method at a time, and then it would say, okay, now this method can't be found. However, we're dealing with entities. It's something we're very familiar with, and it's not something that we need the test to be telling us how to do this, because we know how to create entities. And so I think that was a much faster approach and a more sensible approach to doing that. Bit of a hybrid thing. We got it to tell us that initially we didn't have the order. We went and created that order, and then we knew what to do from there. And our assertion is something that we've already created. So this is going to serve us well for when we're creating new records and testing that we have created our entities, etc. In the next one, what we'll do is we'll actually update an existing entity. In this one, we're going to test that an order can be updated. Now, this might not be something which I would normally test, because basically it's only Doctrine ORM functionality that we're testing. What we're going to do is create a record, and then after we've created it, set new values on it, and then persist and flush it again and check that those changes have been recorded in the database. And so, like I say, it's purely Doctrine ORM functionality, but I think it'll be something which is nice to have just to show you a way of testing that once a record has been created and updated, how we can actually test that it its state has changed in the database from what it was previously. So I think it'll just be a nice little test to have in our arsenal here. So let's go and get this started. What we want to do is create a public function, and this will be called an. Let's give ourselves a bit of room, otherwise it won't be a very good lesson. So an order can be not created, updated. An order can be updated, and this is going to be a test. Okay, so let's go and look at what we had previously. In our previous test, what we did was we had this set up. Now, if you think about this, if we're going to be testing that an order can be updated and deleted, it means that we're going to need, in our setup, we're going to need to have an existing record, an existing order record. So I think all of this here is a candidate to put into the order test setup method. So let's do that now, and it's called setup. And so we need to keep this parent setup, because in there, that is where the entity manager and everything is all defined. So first we're going to call parent setup, and then what we're going to do is we'll just take all of this, actually paste that in there, and then just customize it. So we're going to need a delivery name and delivery address, and I think these will be one of the things that will change. We'll actually change the delivery address as part of the update, and then we'll persist and flush. And so let's have a delivery name and a delivery address property on this test. So private, and it is a string, delivery name, and then we'll remove these, and this will be the property. So delivery name and delivery address. Okay, good. And then we persist the order. Okay, I'm happy with that. And then what we'll do is we'll actually run this test again first. The order can be created, and make sure we've not broken anything here. So in the setup, an order is being created. Let's actually change these values here. Delivery name and delivery address. So we're still making the same assertion that there is an order in the orders table with a delivery name property of this delivery name and a delivery address of this delivery address, and that's what has all happened, has all been created in the setup method now instead. So let's actually go and run this, and we'll just work on it one step at a time. An order can be created. And so we've still got one test, one assertion. We've not broken anything there, and we now have a nice little setup which we can use in our next test. An order can be updated. Okay, so just behind the scenes there, I've created our placeholders for our setup, do something and make assertions. The first thing we're going to need is our order. So if you remember how we grabbed a product using the repository, so order equals, and we need this entity manager, then we need to get repository for an order. So get repository order class, and then find one by, and we shall use delivery name. So let's just drop onto another line here, delivery name, this delivery name, and so there we should get an order. Let's actually just go and have a little sanity check and make sure that we do have an order, and we're just going to dump this out, grab the name of the function, and so it's going to be an order can be updated. So PHP vendor bin PHPUnit tests order test, and I'm filtering for the test and order can be updated. Okay, and so here you see our order. ID of 1, delivery name, Ringo Starr, delivery address is this, and the created at is a date time immutable. So, great stuff. We know that this is working. Now what we want to do, we'll have a variable called new address, and we'll have an address of 9 Newcastle Avenue, Liverpool. I'll let you Google that one and then do something. So what we want to do here is actually with our order we need to set the delivery address. So let's have a bit of auto completion here, I think. So that will just give me a little bit of auto completion, which will make sure that I don't have waste time with typos and stuff like that. And the delivery address will now be the new address. And so we need to persist and flush the same way as we do before. So all we're doing here is getting our order, setting the delivery address to something different, and then it's exactly the same as when you create an entity or create a record. You just persist and flush, and then we'll now have an updated order, hopefully. So we need to make assertions, don't we? Let's go and take this. What we'll do is we'll do an assert database has to assert that we have a record in the database with the new delivery address, and we also want to do assert that we don't have a record in the database with the old delivery address, just to make sure that everything has worked the way we wanted to. So assert the database not has, and then it was the original delivery address. Okay, so I hope that makes sense. What we're doing here is we're finding our order. This has been created in the setup method here, and then we are creating a variable containing a new address, and then we're just going to set a new address on the order, persist and flush the order to make that change permanent in the database, and then we are making an assertion that the order has been updated in the database and that the delivery address is now set to the new delivery address, and we're just going to do a check that we don't have any hangover in the database and there's not a record in there with the previous delivery address. Let's actually go and run this now. So PHP vendor bin PHPUnit orders test, and order can be updated. Okay, and so we have one test, 2 assertions, all green, happy days. In this one, the original plan was to test that an order can be deleted. Having thought about this, how wise is it to be deleting orders? I think a better solution would be to test that an order can be cancelled, and we can have a cancelled at field in the on the order entity in the orders database, which will tell you when the order was cancelled. But deleting the order, completely getting rid of it, I don't think it would be that wise. I think it's possibly something that you might want to go and have that record and have that data available to you at a later date. So let's keep it where it is, but actually change the way that we're going to do this. And so we'll call this test an order can be cancelled. Okay, so public function. Okay, so we're going to mark it as a test with an annotation, and just like in the previous test where we already had an existing order, let's do the same thing there. And then what we want to do is, instead of where in the previous one what we did was we set a delivery address, what we want to do here is set a cancelled at property, and we want to set that to the current time. So we'll say we'll have a variable called cancelled at equals new, and we'll just use a date time again. So date time immutable is fine, and so this will default to the current date time. And then in our do something, what we want to do here is actually set the cancelled at field. So order set cancelled at, and we're going to set that to our cancelled at variable, and then we just want to persist and flush again. Let's go and grab this and copy that. So paste that in there. we're persisting and flushing. So persisting is we're telling the entity manager about the entity, about the change, and flush will make it permanent in the database. And then we just need to make assertions. So make, and again here I think we can go and copy and paste and do some customizing. What we're going to do is assert that the database has, and it's going to be almost the same, except it will be, the delivery address will be the same as what it started out as, because it is going to be the cancelled at field which has changed. So cancelled at, and that will be cancelled at. So you're probably thinking right now, yep, this is going to fail because we haven't even created a cancelled at field in our entity. But let's get the test to tell us what the problem is first. So copy this, and then instead of an order can be updated, we are saying an order can be cancelled. Okay, called to undefined method set cancelled at. So we need to go over to our order and create a cancelled at property and our cancelled at getters and setters. So it's going to be similar to created at. It's going to be a date time private cancelled at, and there is going to be a slight difference with this because I don't think it's something I've mentioned yet, but by default, unless you specify otherwise, all the fields are not nullable. Okay, if you want a field to be nullable, you have to actually specify it here. So let's get the name of the field correct first. So this is going to be cancelled at in the database. That's what we'd like the field to be called, cancelled underscore at. And then we need to say nullable equals true. And this means that by default, or this means that the field will be nullable. If we want the default value to be null, we can do this. Cancelled at equals null, and that means that the default value for this field will be null. And so we'll also say that it can be a datetime immutable or null. So if you did the first course with me, we covered this stuff. The question mark there before this means allow null or datetime immutable. Okay, so this is pretty good. And I think we've covered everything there. Now let's scroll to the bottom. I'm just going to add a getter and setter for this. So getters and setters, cancelled at. And let's just go and check what values it's created for this. So set cancelled at. I'm happy with that. And get cancelled at. And so let's go back to our test and run this. Okay, so object of class datetime immutable could not be converted to a string. Orders test line 90. In fact, I'll put my lines here. Line 90. Okay, so it's within this check where we are saying assert database has, and the message we are getting is object of class datetime immutable could not be converted to a string, and then it's saying database dependent test case, line 36, line 58, line 59. Let's go and see what is going on there. So if I hit 36 as key value string, so if you remember when we create this method here, we went through an array of criteria and we converted it all to a string, but this isn't working because our value in this case isn't actually a string, it is a datetime immutable. So I think what we need to do here is allow for the fact that sometimes our values will be dates. There will be other values, there'll be integers, there'll be floats, strings, they'll all be handled by this, and there'll be no errors, there'll be no exceptions. However, a datetime immutable, what we need to do here is actually say if value instance of, and it's going to say going to be datetime interface to allow for datetimes and datetime immutables. Then what we need to do is we need to format the value as a string. So we'll say that value equals value format, and we'll just format it in year, month, day format. Year, month, day. Okay, and so this will now take our date time and convert it to a string, and so that means that our method should be happy. It will take that value and concatenate it with the rest of the string. Let's actually go and test that theory now. So we'll run the test again. Okay, and so this time it's happy, the test is passing, and we're not getting that error. And what that also means, of course, is that this assertion is passing, so we're able to test that cancel that has indeed been updated from what it was originally in the database, the default being null. Let's have a little recap there just in case that wasn't clear. If you're totally clear with that, just skip on to the next video, but not everyone might be as quick on the uptake as you. So same setup, we got our order, and then we created a cancelled at variable, which was a datetime immutable, and we set a cancelled at, or we updated the cancelled at value to be what we set here. Persisted and flushed it, and then we just asserted that we had that value in the database. We came across an error because when this assertion runs, what it's doing is it was expecting strings. When it does this conversion of all the criteria, for example, when it's showing that there's a failure message, we wanted to be able to show the key value pairs and why the record could not be found and what the keys and value pairs were. And so the problem was that all the values so far have been strings, so it's been quite easy to just create this little string here, this concatenated string. But in our case, we came across a datetime immutable, which obviously cannot be concatenated with a string, so we formatted it as a string in the format year, month, days. Okay, so that should cover off that one. In fact, I think what we'll do now, because we've made a change to one of the core tests here, which is used in all of our others, what we want to do is make sure that none of these break. We've also added a new field, and so what we want to do is make sure that nothing else has broken. And in fact, what I will do is I will just, where we're doing this assert database has, we're saying in our order that the default is null. Let's just go back and find this. We're saying that for the cancelled at, we want the default to be null. Let's actually check that it is being created with a default of null. In our order can be created test. Let's just say cancelled at, and we're just going to check that it is in fact null. Okay, and then what we'll do is we'll run them all. If nothing breaks, then we know that this new check that we're putting here is working. So I'm just going to remove this filter and run orders test as a whole. Okay, 3 tests, 4 assertions, no reds, everything's working. Let's move on. We now need to focus on this. So when we add a product to an order, we need to create that relationship between the order and the product. Now initially I called it this for lack of a better word, but if you think about it, what does a product become in the context of an order when it's been added to an order? It becomes an item, and seeing as we said we're actually going to model this, we're not going to create a many-to-many join table between orders and products. We're actually going to create its own entity which will have a relationship with both the order and the product, and I'll show you that relationship in a second. But let's change this to item. This is what we'll refer to it from now on, and we're going to create an item entity. Now let's have a look at the relationship. And so this is it here. In the middle we have our item, on one side we have the order, and on one side we have the product. But the relationship will be a many-to-one relationship from item to order, because if you think about it, you can have more than one item in an order, and so that takes care of that side, and that's fairly simple to understand and to follow. Then we have a many-to-one relationship with a product, because the way you think about this is one product can spawn many items. There can be you can have 3 times that product on an order. You can have that product can belong to multiple orders in multiple quantities, and so for that reason we're going to need to have a many-to-one relationship between item and product. I did do a recording on UML if you've not watched that one, and that shows you how to model relationships and things like that. And what this means is the little arrow thing with the three prongs, that means many, and then that means a many-to-one relationship. So that's all that means there. So that's our relationship sorted out. That's our schema. In the next one, what we need to do is go and actually create our item entity, and we'll do that using a test by actually trying to add an item to an order. Let's now go and start creating an item. So like I said in the previous one, the way I'm going to do this is with a test. Now, whereas we had a products test and we had an orders test, I'm not sure it would make much sense to create an items test. It's a possibility. However, you're always going to need an item in the context of an order. So rather than go and create an items test and test things in isolation and use dummy values, what we'll do is we will actually use orders, use products, and so I'm going to add this to orders test, and I'll just test that an item can be added to an order. Okay, so we'll head to the bottom of this test and we'll just create a new one here, and like I say, we'll call it an item can be added to an order. Let's now mark this as a test using annotations, and this one could become quite complex because if you think about our setup, we're going to need an order, we're going to need a product, we're going to need to figure out how we test that an item has been created and how it relates to the order and the product. So this one could get quite gnarly, so always work methodically, add your steps. So we're going to need setup, do something, and make assertions. Let's think about our setup. We're going to need what comes first in everything. So before you can create an order and before you can add an item to an order, you're first going to need a product. You can't create a order without products. So need a product. And then in order to create an item which relates to product and order, we're going to need an item. You're going to need an order. And we know we have one of these because we are creating one in our setup. So we can reuse this. However, we will need to actually create our own product for this test. Do something will be create an item. So we need to create an item using references to the order and the product. And then somehow we need to make assertions that we have actually created the item in the database. So check that the item has been created. What I think will be beneficial to your understanding is if you have a preview of what we're going to actually end up with in our database. So I do have a practice project which I use sometimes before I actually go ahead and create the lessons. So I'll show you what we're hoping to end up with. Here I have an items table and we have an ID, which is typical for all the tables. Then we have an order ID, and you'll see here this is a foreign key which points to the orders table and also the ID field on the orders table. Then we'll have a product ID, which is the foreign key that points to the ID field on the products table. And the only other things we need really are the price and created at. Like I said, we don't need quantities and things like that because if there are two of the items added to the order, we're just going to create two items records. And the reason behind that, it just gives you that extra flexibility. It means you can do things like removing one item from an order quite easily and actually marking when it was removed, or things like if you do like buy one get one half price, you know what you've paid for each item. So always helps if you think about your schema, what might change, what might your requirements be in the future. And so I think this is the best way to go with this. Anyway, back to our test. Let's actually start writing this out. So here we have the full creation of a product. Let's just go and grab that and we'll paste that in there. Doesn't come in the do something. We actually need to do that here. Now, you may have remembered me saying that when you flush, that means any entities which are under the management of the entity manager will all be persisted, updated, created or whatever at that point. So you'd think that we won't need to put this step here, and then we can do it after we've created our order and our items. So that will work with the order. However, in order to create an item which relates to a product, the product actually already needs to have been persisted and existing in the database. Otherwise, it won't have a foreign key, it won't have an ID key in which to relate it to. And so that's why we need to flush that there. Then for the order, we've actually created one. And so we'll just say order equals, and we can borrow a line from here, can't we? Yeah. Let's just paste that in there. So just to remind you how that was done, we got the entity manager and we said get repository order find one by, and we use the delivery name to find one by, and we have a delivery name property on our test class on our order test, so we can access that. Okay, so next, where are we up to? We need to do something. So now we actually need to create an item using references to the order and the product. Okay, so this is where things will start to get a little bit more technical, because we've not actually looked at Doctrine ORM relations yet. So there'll be quite a bit of explaining in this one. So we'll say item equals new item, and we're going to drive it all out with a test, so, or most of it with a test. So what I'm going to do is I'm going to create the item, even though we don't have item entities yet. We've not created item entities. I'm going to set the values, I'm going to set the order, the product, and all the things that we need, and then try and persist it. We'll get the error, and then we'll take it from there. So item, and then we need to set order. And the way you do it is, even though we are referencing using keys, order ID is going to reference the ID field on the orders table. What you do when you actually using relations with Doctrine entities is it's very object oriented. You just pass in the actual object itself. You don't have to think about the underlying database or anything like that. You can actually write all this code and not actually give much thought to the database whatsoever. All you're dealing with is just object oriented code, getters, setters, setting certain objects on other objects, which, if you remember, if you did the first course, what do we call that? We call it composition. And so our item will actually now be made up, our item entity or our item object will actually be made up of other objects, those objects being the order and the product, which is pretty cool. And so item, and then to set the product for the item, you simply do this, set product, exactly the same as what we do for the order. And what else do we need? We need the price, so item set price, and we'll set it to the exact same price as the product. So what we'll do is we will say product get price. And then was there anything else we needed to set? I don't think there was, because the created app, we're going to follow the same strategy as we did for our order and our product, and that will be automatically created when we actually create a new item object or new item entity. And so then we just need to flush it, persist and flush. So entity manager persist, we pass the item, and then this entity manager flush. We now need to make our assertion, so I'm going to go and borrow some from here, but I'm anticipating a problem, because if you remember what went wrong when we actually first tried to use a date, we had to go and change our method to use to convert any dates to strings, and this is what we did here. We made this check. However, here what we're going to be doing is checking for objects, so we're going to be checking that order is this particular order. We're going to be checking that product is this particular product. Those are not strings, they're entities, and so this could start becoming messy, can't it? If we're saying if value instance of order or instance of product, or even if you want to use polymorphism and just say instance of entity, we're still going to start creating a bit of a mess in this one. So I'm going to avoid doing that, and we're going to have to come up with a different strategy, I think, for actually testing it against the database. what I'm thinking is we'll actually create a brand new assertion where instead of checking against an order object or a product object, we'll actually go and just do a raw SQL query and test that there's an item in the items database with an order ID of this and a product ID of this. So we won't be checking an item entity, we'll be actually checking the items database. And I think that'll be the best way to go with this. But I'm getting ahead of myself. We're going to come to that later on. Let's solve one problem at a time. And so here, what I'm going to do is I'm just going to test that we have an item in the database, or we have an item entity with the given price, i.e. the same price as the product. So item, and it will be product get price. Okay, so I'm going to run this now. Obviously it's going to fail, but it'll tell us what we need to do, what our next steps are. And so I'm filtering for the name. An item can be added to an order. And so we have our first error, app tests item not found. So we need to go and create our item entity. So over to source, entity, and just next to object or order and product, we'll create a new entity here. So I'm just creating a class, it's called item. We'll go back to our test and we'll actually use our new item entity instead of this. Okay, and then we can run our tests again. And we have our next error, call to undefined method, app entity item set order. Okay, so we don't have any methods at the moment, we don't have any properties. What I'll do is I'll quickly zoom through this and create the properties that we need. Okay, so these are the properties that we're going to need. We can actually start annotating this as an entity. So if we say use mapping, and then we've done this before as ORM, and then we can actually go and borrow from our other entities, because like I say, if you cut and paste stuff that which you know it works, then it makes life easier than having to try and remember this, because Doctrine entities, if you've not used them much, I've used them quite a lot and I still can't remember this stuff, mainly because I always cut and paste it, I guess. So items, so we're saying this is an entity and it's going to reference the table that which sits behind this entity will be the items table. Then we need our ID stuff. So this is the one which I always forget, mainly because I don't just work with MySQL, I also use Postgres and I also use Oracle in the day job, so it can all get quite confusing really. Let's paste that in there. We can copy a bit of this and then remove that and remove that. Okay, order. This is going to be a little bit more complex. So the relations, I'm going to come back to these and we'll cover them in the next recording. Created app, we've done this one before. So I can borrow this here. And if you recalled what we did when we actually did this, what we want to do is set the created app field every time an item is created. So in the constructor, we will say this created app equals new, date time immutable. Okay, great stuff. So we've sketched out our entity there. What we'll do is we'll take a break, and in the next one we'll actually cover the relationship between orders, entities and products, and how that works using Doctrine annotations, which is going to be quite complex and it may be new to you, so I think we can use a dedicated video all for doing that. In this one we're going to figure out how to actually create those relationships between entities using annotations on our entity. Before I go one step further though, I'm just going to clean up some things which I saw at the end of the last recording. Here, for whatever reason, I'd spelled this variable name wrong, so it should be item set price, and obviously here when we're doing the assert database has, I'm actually checking price, not delivery name. Okay, and so I think what we'll also do is just run our tests and see what state we're in with these. So PHP vendor bin PHPUnit tests orders test, and then I'm filtering for the an item can be added to an order test. Okay, let's run that, and we've still got the exact same failing test for the same reason, because call to undefined method app entity item set order, because we haven't fully defined our order property and we certainly haven't set the setters, getters and setters for our order and our product. And so that's what we're going to do in this one. And the way we create a relationship in our Doctrine entities is, again, using annotations, but this relationship, if we remember what we said, was going to be a many to one, many items to one order. Okay, and so it's the same as when we do columns or when we do anything like that. It's at ORM and then the name of the relationship. And I should get some auto completion here in PHP Storm, and the first one which pops up is many to one. Believe it or not, that is the most common type of relationship in any database, in any tables. Many to one is the most common type of relationship, so that's possibly why that has popped up first. ORM many to one, and then within the parentheses we need to point it at the entity which we are referencing, the target entity, which in our case is an order. And so you don't need to put order PHP or anything like that, just the name of the entity. It's in the same namespace, which is app entity, so you don't need to include namespaces or anything. You just need to put the name of the actual class, the entity that it's referencing. Okay, and then if you remember what we said when we looked at the database, what we are actually wanting to create are these here, which are join columns. They're joining our items table to the orders table, and so we actually have to tell Doctrine ORM to do that for us. And so ORM, and this time what we are saying is join column. And one thing that's interesting about this, and it's quite a common gotcha, is that normally unless you specify that a field must be allowed to be null, then the default is for nullable to be false. However, when you're dealing with join columns, you actually have to tell Doctrine that nullable should be false. And so we'll do that, and then we also want to give it a name, and so the name of this field in the database will be order ID. I think with the naming conventions which Doctrine uses internally, that is what would happen by default anyway, but I'm just being explicit here. And so that's how you annotate this relationship. We're creating a join column called order ID, and this is going to be a many to one relationship with our target entity, which is the order. And so when we actually go and run our schema uploading or our schema updating, it will actually create the fields, and it will also create the foreign key constraints with those foreign fields with the ID field on the order table. And so product is going to work exactly the same. What we're going to do here is just go and paste that in, and this time we're creating a many to one relation to the product. And join column is exactly the same, nullable equals false, but this time the name will be product ID. I think we're in a position now where we can go and add our getters and setters, and then we'll be able to run the test again. So again, using PHP Storm, I can open up this little generator menu using Control and Enter, and then I'm looking at the getters and setters. I'll just add them all in one go, but I'm actually going to remove some. So set created at, this gets done automatically when the record is when a new item is created. A created at field gets populated there, and also set ID. This will be done by the database in MySQL. So what I'll do is I'll slowly scroll through this so you can see exactly what I've created. Okay, so we have our class item, we've annotated it as an entity and said that the table will be items. We've created our auto incrementing ID using these annotations here. We've said that the price will be an integer. We've created a many to one relationship with the order, and also said that we're creating a join column. The name will be order ID. Did this exact same thing for the product. Created at, this is pretty standard now. This is what we've done for all of our entities, and in the constructor we set up the created at, and we removed the ID set ID field. So we have get ID, get price, set price, get order, set order, get product, set product, and get created at. Okay, so I think we're good. Now let's go back to the test and see what we're up to. Okay, so we run the test again and we have one test, one assertion. There is actually an item in the database which has a price of this. However, we don't have anything which tells us that this item is actually related to this order or this product. So there's a problem that we need to solve. And in fact, what I'll do is I'll just create one other check, because I'd like to be able to check that we can retrieve the item off of the order. Because if you think about the relationship there, if we create an order, obviously we'd like to see what items are in that order. And so I'm just going to add another assertion. Check that we can retrieve items from an order, e.g. order get items. And so this, I'll say assert count, and we'll come on to why I'm saying that shortly. And then we'll just say 1, and we'll say order get items. And so we don't actually have a get items method on our order at the moment. If we look through this, there is no get items method there. So obviously this test is going to fail, but it'll give us a nice starting point for the next recording. Let's go and run it anyway. Okay, call to undefined method app entity order get items. So this leads us onto a nice little starting point for our next recording, and that is how do we define the inverse of that relationship. Now we want to be able to do something like this. We want to be able to retrieve the items off of the order. Let's go back to our item and actually look at this relationship. So we said that it's a many to one, and when you have many to one relationship, it is the many side, in our case the item, which is the owning side, because if you look at the database, that is where we actually create that relationship. So on our items table, we have our order ID field, which has a foreign key mapping to the ID field on the orders table. If we look at orders, there's actually nothing in here which relates to items at all. You cannot look at this table and know anything about items. All the information regarding that relationship all resides on the items table, and so that is the owning side. However, we want to be able to do this. We want to be able to get the items relating to an order. We can do that, and what we need to do is actually create an items property, which will be a one order to many items relation with the item, and then that will be mapped as the inverse side. So let's go over to our order and we'll actually have a go at this now. So where can we put this? We'll put it above the dates. I usually like to put the dates last. Okay, so private, and it will be items. Okay, and so like I say, this will be a one to many, and so the way that we do this is one to many. So same as what we did with our order, with our item, where we have a target entity, we do the exact same thing there. So target entity will be item, except this time we also add this here, mapped by, and it's actually the name of the property, not the name of the object or anything like that. It's the name of the property, and we call the property order. Okay, so order, and if you saw the auto completion, they actually popped up order and then in brackets many to one. Okay, great stuff, and that is actually all that you need to do to define the inverse. However, we want these methods, don't we? So let's go and have a look at the methods we created on our item and see what names we gave them. So these look okay, they do make sense. Get order, set order, yes, we'll be doing that. Get product, set product. Let's drop down to the bottom of our order entity. I'm just going to let PHP Storm do its thing and add getters and setters, but when you'll see the names, you'll see that they don't quite make total sense. So set items. Would we be setting items on an order this way? something doesn't ring true there. This one seems okay, and that's actually the method that we were calling in our test, and so that one makes sense. You want to retrieve all the items for an order, so having a method called getItems does make sense. For the actual setting of items, what we're going to do is actually have a method called addItem, and that means we can add one item at a time to our items array. So this is going to actually be an array collection. First we need to define that, so we're going to come back to this again in a second. What I'm going to do is go up to the constructor, and so here what we'll say is when we initialize this, we'll say that this items equals new array collection. Okay, and so if you did the first course with me, you'll know all about array collections because we covered it in there. But basically, this gives us an object which can be iterated over and treated as an array. What we would do is to add an item to it. We'll say this items, and then we'll just add an item to it like you're adding to an array. And the reason you can do that, if we go and have a quick bit of revision, if we look at array collection, it implements collection, and if we look at that, it has the array access, and so that is what we use in order to be able to access an object like it is an array, and that's what we do with collections. Okay, so now we've set that, we have set our inverse of the relationship here with items. We seem reasonably happy with what we're doing here. Public function add item, this items equals item. There is one other step, and so in order for this to actually take place, because at the moment it won't happen by magic, what we need to do in order to add an item to this array collection is we need to go back over to our item, and when we actually set the order, we need to say, and in fact let's add our type hinting there, so order and then order add item, and we're just going to add this. And so let's think about what happens here. When we actually set the order, what will happen is it takes an order as the argument, that gets set, and on the inverse side the order adds this item to its own items array collection, and so that's what happens here. Had a lot to take in there, but the best way to fully understand it is just go through the code line by line, study it, see what we've added, and it'll all make perfect sense to you, I'm sure. Okay, so let's go back and actually run our orders test again, and so we're going to run this method here. PHP vendor bin PHPUnit tests orders test filter for an item can be added to an order. And so we get one test, two assertions. We now have a passing test. Okay, great stuff. So what will be good is if we actually add multiple items to the order, and then we can assert that the count is actually greater than 1, and we'll do that in the next one. Let's now do a similar test as the one we've done here. So we've just tested that an item can be added to an order, which has given us a reasonable amount of confidence. Let's test that we can actually add multiple items to an order, and that will give us greater confidence that it is actually a many-to-many or many-to-one relationship and a one-to-many on the inverse, which has been defined. And so it's just a bit of thoroughness really more than anything else. And so I've copied that test, and I'm going to say multiple items. Multiple items can be added to an order. As part of the setup, what I shall do is I will create a multiple, and we'll just go with 3. And that means I'll be able to use it in the assertion, and also I'm going to create a for loop which will loop over and actually create the items one at a time. So do something. Here is where I will create the multiple items. So using a for loop, I'll say I'll start off with I equals 1, and then while I is less than or equal to multiple, and then what we'll do is we'll increment I by 1, and so I just need to add the braces and then drop this into here, and the flush can come afterwards. So we're doing the same as what we did before. On each iteration we're going to create a new item. The order will be the same, the product will be the same, we'll keep the price the same. Then we're going to persist each item, so bring each item under the knowledge of the entity manager, and then at the end of this we don't need to flush on every iteration. We can have multiple items under the management of the entity manager and flush them all in one go. And so our assertion here will be the same. We're going to assert that the database has an item and the price is the same as a product price, except the one change here is that our count, we're going to say multiple. Okay, so we're checking that there are 3 items which have been created and which can be retrieved off of the order. So let's go and actually run this test. And so it's the same test, PHP vendor bin, PHPUnit tests, orders test. So this time we are filtering for multiple items can be added to an order. Okay, and we get 1 test, 2 assertions. So our 2 assertions are that the database has the item and that the order, 3 items can be retrieved off the order with our getItems method. So this is pretty good. It can give you a reasonable amount of confidence that both sides of the relation are being created and that the order ID is actually being set because we know that we can get the items off of the order. However, we don't know that for sure. We have nothing which is telling us that this order ID has been set on the item and this product ID has been set on the item, because if you remember we had this problem in that the entity actually retrieves an order, doesn't it? And that was going to become messy because we're already put in this little hack here to see if we're actually checking a date. I don't want to be checking against entities, so I think in the next one what we'll do is we'll actually have a look at creating another assertion which actually doesn't look at an entity, it actually looks at the table and looks at the fields on the table and make assertions using that. Now we're going to have a look at creating another custom database assertion, except where we can actually look at the underlying columns in the database. So for example, I want to actually be able to check, do we have a particular order ID, do we have a particular product, which I can't do with the existing assertion that we have here where we are checking against entities. So I think I'll actually keep this name for what I want to achieve, which means I'm actually going to go and change this to assert database has entity. Now there's a way I can do this in PHP Storm where it will actually find all of them and change them at once. And so if I select it and then if I hit Shift F6 and then I just change the name of this to entity and hit enter, if I actually go back and look at my orders test, you'll see that that's changed. So let's actually run all of our tests, not just the orders test, and see if everything is still working okay before we move on. Okay, 13 tests, 21 assertions. I've changed something there which is used in several places and I know that it still works because I've run all the tests and nothing is broken. Okay, so I want to have an assertion called assert database has still. I like the name, so what we'll do is we'll actually put that one first and we'll just create an empty method, placeholder method for the time being. Assert database has. Okay, and so how are we going to make this work? The easiest way to actually drive out this and figure out the functionality would not be to use things like items, because in order to create an item in the table, because of the foreign key constraint, it means I've also got to create an order, I've also got to create a product. I know that my products table has no such dependencies and no foreign keys to other tables, so the easiest record to create would be a product, I feel. And so what we'll do is we'll go back to products test. I'll actually drop a new test in here. So I've got one called a product can be created. Let's think of a good name. Okay, let's just call it can check a product is in the database. So I'm going to create a test, and it's going to be very similar to this one except with different assertions. We'll say public function Okay, so can test a product is in the database, and we can actually borrow some of this, can't we? Because like I say, we're going to be, most of it's going to be the same, but the assertion is going to be different. So we'll paste that in there, and then we'll just delete these assertions because we're going to use our own new one. Let's actually write the test that we would like to have, how we would like it to behave, and then we'll work backwards and we'll go and actually flesh out the method the assert database has assertion. So this assert database has, and so ideally I just want to pass this two arguments. The first one will be the name of the table, which in this case is products, and then again I just want it to be an array of key value pairs, so field name and field value, the value for that field. So we know that we have a name field on the products table, and we have a name variable which we have set, and we have set it to the product. And so the other one we have is description, and we also have a description variable. So if we go and run this at the moment, it's probably going to tell us that we don't actually have an assertion, and we haven't actually created the ability to pass arguments. So rather than guess, let's actually go and see what we get when we run this test. So PHP vendor bin PHPUnit tests products test, and I'm filtering for can test a product is in the database. And so what we get is this test did not perform any assertions because our assert database has method is actually empty. There are no assertions being performed like there are here in our existing test where we are asserting for certain Boolean values. So what we need to do is start figuring what we do with this assertion. We know what our two arguments are going to be. We're going to need the table name, and then we're going to need an array of attributes. So I'll actually use some typing here, and I'll say the table name will be a string. Just a good habits to get into. You probably have noticed that I don't always do it, but I tend to get my code working and then go back and put this stuff in afterwards. But I'll try and keep good habits. Okay, and so what we want to do is actually, if we look at the Doctrine documentation here, this is what we're going to use. We're going to use some, if you remember what we did with PDO, where we actually we binded parameters to a query. So we're going to need to do something like this: select star from products, where name is this and description is this. However, we want this to be reusable. So one early problem I'm anticipating here is we don't know how many attributes there are going to be. So we're going to need to solve that problem. I'm thinking we're probably going to need to do some kind of looping which loops over each attribute and adds it to the query. What I'm going to do here is have a think about this, and I'm going to drop some comments in which will explain the steps that we need to go through. Okay, so I've created a handful of steps here. Let's go through them one by one. Get SQL placeholders, parentheses, column names. What do I mean by that? If we look at this here, it's using named parameters. So I want to do something similar. So where it says select star from users, where name equals, and then we have this bound parameters. So what I need to do is get the name. So our attributes comes in key value pairs. So I'm actually after the keys. So the way I'm going to do that is say keys equals, and the way to get the keys from an array is to say array keys attributes. Okay, and so let's just dump out one step at a time and make sure that everything is working the way we expect it to. So we'll run the test again, and so here we have an array, and we have the field names, don't we, which are the keys. So far so good. Now we need to create the base SQL, because if you think about this, we're always going to need to be checking against one column. However, if we have multiple columns, we're not going to know how many multiple columns we have. So let's solve one problem at once, and we'll just create our base SQL. And the way I'll do that is say SQL equals. I'm just going to say select one. This value doesn't matter, it can be select anything, but we just want to know, are any records being returned? And if so, then we will get one back for this record. However, if no records are returned, as you'll see shortly, what you would actually get back from the query is, when we execute the query, is we will get false when we try to fetch the results. So select one from, and then it needs to be the table name, and then we are saying where, and initially we just want the first key, so keys equals, and then we add our parameter binding here, and again it's just keys. Okay, and so if we actually dump this out, okay, so select one from products where name is name. So that's formatted nicely. However, I do see a problem with this, and that is that how do we now get at our remaining, we need to create a loop which goes over our remaining attributes. However, we need it to start at our second attribute because we have already added key number one, which is the name, to the query. We don't want to be starting at that again. And so the way that I can remove the first item from an array is to use shift, array shift. So what we'll actually say is first column equals array shift keys. Okay, and so this time, instead of using keys and using this messy square brackets, I can just say first column here. I can also just say first column here. And so there we've solved a couple of problems in one go. We've actually removed the first item, which is name, from our keys array, and we've also been able to use it here. But what it also means is that our keys array will now start at the second item, so index 1, well, what was index 1 in the keys array. So let's actually just go and dump out all of our variables here and see exactly what we have. So we'll look at keys, we shall look at first column, and we shall look at SQL. So this is a good way to work, you know. If you've done quite a lot of heavy coding and you've been setting values, removing items from arrays, stuff like that, always just check and test, go back, check what you've got. Okay, so for our keys, what did we expect? Well, we've used unshift or array shift, which removes the first item off there, and so we expect our keys now to just have a description, which it does. Our second thing that we dumped out was the first column, which is the name. That's good. And then our third thing that we dumped out was the SQL, which is select one from products where name equals name. So far so good. What we need to do now is, if more than one filter needed, loop over the remaining attributes. So all we need to do here is just loop over our keys. And so for each keys as column. Then what we want to do is just add to our SQL. So SQL append, and we need to append and then same again, column equals colon column. If we can get that right. Okay, so that should complete our SQL. It should loop over each item in the attributes and then, or each item in the keys, building up our SQL. Let's see what it looks like. Select one from products where name equals name and description equals description. Okay, so this is perfect. We know our SQL is good. What we need to do now is actually create the statement and start binding the values. Let's go and have a look at the Doctrine documentation and see how that works. So we need to create the statement. So we need to get a connection. I know I can get this from the Entity Manager as it happens. Then we need to start binding. And again, we don't know how many items there are to bind. So again, I think we're looking at a loop here. Let's go over and see how we can work this out. I can get the connection with this. Con equals this Entity Manager get connection. Statement equals con prepare, and then I pass in our SQL. And now we need to actually start binding the values. But we have a problem, don't we? Because we've actually removed one of the items from our keys. So just looping over this isn't actually going to work because we're going to be missing a key. What I can do is where I actually set the keys, I can perform another assignment at the same time as I do this. I'll explain this to you in a second. So SQL parameters equals keys equals array keys. So when I perform this assignment here, we're actually dealing with arrays. If this was an object, it will be the assignment will be done by reference, but when you actually do assignments using arrays like this, I actually create a copy. So this is not this. If I alter this, this one will remain the same. It won't be altered in the same way as what I've altered this one. And so let's actually try this out. What I'm going to do is actually use SQL parameters here. And so I'm using array shift to remove the first item. Just dump this out just to prove that when I perform the array shift that this now does not match this. Okay, so we'll dump out SQL parameters and keys. Okay, so SQL parameters now only has a description, whereas keys has a name and description. And so that means we can actually use keys for doing our binding because we know that everything is still there. And so what we shall do here is we'll again do a for each, except this one, and in fact this should have been SQL parameters. So there we are now looping over SQL parameters as column because that is the one where we removed the first item. And so for this one, when we actually come to do the binding, keys as key, and let's go and get our binding syntax. So it's statement bind value name we'll paste that in there. So statement bind value, and that will be key, and then the value we are binding is actually the attributes array that we pass in. We shall use the key to get each value in that array. So attributes key. We now need to execute the query, so I'll say result equals statement execute query, and then in order to actually see what we've got, I will say result and then fetch 1, and so we shall dump that out and see what we actually get here. And hopefully we should get 1 if a result has come back, if a record has come back from the database. If not, we'll get false. Let's go and run the test. Okay, and so we get 1. Let's go over to our products test and we'll just change this description to a load of gibberish, and hopefully we should see false. Great stuff. So I think this makes it very easy for us to create an assertion because we're already getting a boolean in one condition there. We can cast it to a boolean. So if we get a string 1, if we cast that to a boolean, it will give us true. If we cast false to a boolean, it'll still give us false. So this assert true, and then we'll say bool result fetch 1. Okay, so the test has failed because it's saying you've failed asserting that false is true. So even though the test has failed, this is actually a good sign. It shows us that our test is working. Let's go back to products test, change this back to description and run the test again. So we do know that our assertion here is doing what we want it to do. What I'm going to do with this test though is, or with this assertion, is I want to go over it and clean it up a bit because there's a few comments in there, and we also need to come up with a failure message, and I'll probably inline all of this so we can just perform this assertion all in one go, and so I'll do that in the next one. Now let's finish off our assert database has assertion. What we want to do is clear out some of the comments which are just creating a mess and adding noise, and also I'd like a failure message like we used in our assert database has entity, so we can use the same as key value string little helper function which we created here, because this will work perfectly because we're only actually dealing with strings in this instance. So where can we go and drop this? Here. So what I'll do is I'll actually borrow a bit of this and then we'll just customize it. So always helps if you've already got a bit of code which you can just go back to and customize it. So that bit can stay the same. I used criteria in the other place, and I think it's actually a better name, so I'm actually going to just find all of those attributes and change that to criteria. Okay, so that'll be better. In fact, after I've done that, what I'll do is I'll just comment out this new stuff and I'll just run the tests again just to make sure, because sometimes when you change things it breaks things. Okay, so I've still got one test, one assertion. Let's actually go and change this now for our needs. So key value string, that will create us the string that we want, and what I want to say is a record could not be found in the whatever table name table and with the following attributes. So a record could not be found in the, and we need table name table with the following attributes. A record could not be found in the table name table with the following attributes, and then we are adding our string in there, key value string. So let's actually go and just dump this out and see what this failure message looks like. And we actually need to make the test fail in order to do that, so let's change the description to something nonsensical, run the test. Okay, a record cannot be found in the products table with the following attributes. Name equals this, description equals this. I'm happy with that. Let's go back now and actually just use that failure message in our assertion. So if the test fails, then it will print this failure message. Let's go and run this again. And so we have a red failing test, but our message, our custom message, is pretty good. A record cannot be found in the products table with the following attributes, blah 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 blah. And then the default PHPUnit failure message or assertion failure message, failed asserting that false is true. Great stuff. So what we want to do now is just go through from top to bottom and just strip out any comments which we don't think are necessary. So get SQL placeholder column names. I mean, we've given it a decent enough variable name, SQL parameters. We know that they are going to be parameters which are used in building our query, so we don't need a comment for that. If you use good variable names, you do not need comments. Create the base SQL, so we know what we're doing here. We know what that code does. If more than one filter needed, loop over the remaining attributes and add them to the SQL. So we know what we're looping over, and we know, and we can see that we're appending to the SQL, so we don't need a comment there either. Create the statement, that's pretty obvious what we're doing there. Bind the values, well, it's got a method called bind value, so pretty obvious what that is doing. And then this is the same code as what we used in the other test. We don't need to say that we're executing a query, so we don't actually need any comments in this test whatsoever. It's called execute query, so why would you need a comment? Okay, and so just make sure it's still passing, and then we'll go and change our products test, and we'll use description here. Okay, one test, one assertion, and that completes our custom assertion. So I think that's pretty good, and it's a lot more flexible, or not more flexible because it's good being able to check against entities, but this gives us the ability to look directly at the database and read exactly what columns are being used in the database. Let's just actually go and see what happens with this query if we only pass it just one filter. So for example, we just want to filter for name. Let's see if the test still passes when we do that, because if we do that, it means that we'll have nothing to loop over here, and so it won't add any more and filters onto our query. Let's go and run this. And let's actually run it with a failing test. So we'll use name and make up something. Always be thorough with your tests. Okay, let's see what this says. a record could not be found in the products table with the following attributes. Name equals blah blah blah. And so yeah, it just checked the name filter, didn't check any others, didn't perform any ands, add any and filters, so that's working well. Let's change this back now, and we'll change it back completely. This should be a passing test. And then in the next one, what we will do is we will go and use this assert database has assertion in our orders test, where we are adding items to an order. So I'm back in our orders test, and we're on the test that an item can be added to an order. So up to now we have been testing this by using our old assertion, which was assert database has entity, but we want to use our new one because that means we'll be able to check the product ID and the order ID. So let's do that now. So we'll change this to assert database has. This one doesn't take an entity, it takes the name of the table, and then what we want to do is we're going to check the order ID is the same as order get ID, so order get ID, and then this one we're going to check product ID, so product ID, product get ID. Okay, good. So just make sure everything is okay, and we're still just making an assertion that we have one item or one item on the order. Okay, let's go and run this test. So I'll grab that, and then it's going to be PHP vendor bin PHPUnit. So if I do v /b /type PHPUnit and hit tab, then it'll complete that for me. So if you wondered what I was doing there, so vendor bin PHPUnit, and then we're in tests, and we're in orders test this time, and then we are filtering for an item can be added to the order. Okay, and we get one test to assertion. So let's have a sanity check and make sure it's not passing by accident. We'll give order ID an ID of, we'll just make up something mad, 4567. Okay, so the test fails. Let's read the failure message. A record could not be found in the items table with the following attributes. Price equals 94400, order ID equals 4567, and product ID equals 1. So that was pretty good. Let's change that back and do the same thing and make sure that our product ID is also working. Okay, and so 5767, just make up anything. And again, this works. So a record could not be found in the items table with the following attributes. Price equals blah blah blah, order ID equals 1, product ID equals 5767. Change that back, run the test again, because I don't like to end on reds. Okay, so that works. We've created a new database assertion, which works better with what we're trying to test, and we've actually used it in our test. So that's perfect. In the next one, what I'll do is I'll discuss products with you, because if you remember we defined an inverse on the order. I'll explain why at this moment in time I'm not going to define an inverse on the product, and then we'll move on to something else. Back in our order entity, we actually defined the inverse, didn't we? So we have an item, which is the owning side, because item or order ID is held on the items table as is product ID. But we said there will be instances where we want to get the items. We want to use the order in order to retrieve the items and maybe inspect those. So we added an items property, and we added the ability to retrieve the items. And in order to do that, we also needed to be able to add items to the order when we actually did the opposite in our item. So here, when you see when we set the order on the item, we also added this particular item to the order. So you might be wondering, well, we've defined an inverse on the order side, why don't we have an items property on the product side? And the reason is, would we use it? Why write any more code than what you need? Because it's quite a strange thing to do. Would you ever say product get items? Because there could be thousands and thousands of items which have been spawned for a particular product, but why would you ever want to go and look at all the items for a product. It's unrealistic. If a scenario did arise where you want to do that, then I would say, yeah, okay, create an items property, add the ability to do that. But unless you definitely know you're going to need it, and this is something which I suspect I will never need, I'm just not going to put it in there. So some developers will actually go and define absolutely everything. They'll create the item and then they'll define the inverse on the order, and so they'll think they have to do the same thing on the product. If you're not going to use it, don't do it. Just keep your code lean and mean. The less code you write, the less code you have to test, the less code you have to maintain. If you don't need it, don't add it. Now that we've got all our tests working, we're happy with our orders and our relationship with items and products, we actually need to go and add those new tables to our development database, because at the moment we only have users and products tables. And so if you can remember how we did this, the way we do it is by using this command here: vendor bin doctrine ORM : schema-tools : update. And so that is how I would update it. However, before I do that, I just want to inspect it and make sure that I'm happy with the SQL that's being created and what's going to be created in that database. So I can do this. I can say dump, so it's --dump -SQL, and then this will show me the SQL which is going to be run to create the table. So we've created two new entities. We've created the order and we've created the item, and so I'm expecting to see the SQL to create two new tables here. Let's run this. Okay, and so we see a load of SQL. It's all in black and white, so it's quite hard to read, but I can split them out, and so we'll do this one at a time. I can see my create orders table here. I'm going to copy this, and I've actually created an orders SQL file, so I'll paste that in there and I'll have a quick look at it. And so there's a couple of things that I've spotted straight away, and that is delivery name is in camel case and delivery address is in camel case, whereas we want everything like this in snake case. So in order to change that, we need to go over to our order, and here we have delivery name and delivery address. So I'm just going to say name equals delivery name, and PHP Storm is quite intelligent. It'll sort of guess at this for you. Name equals delivery address. Okay, that's good. Let's go and run this again and see if anything has changed. Okay, so I can see that's changed. Create table orders. Delivery name is snake case. Let's go and paste it into our file to make it life a bit easier for ourselves. So we'll remove this. We'll paste that in there. And I've just zoomed through that a little bit behind the scenes, so just check all of our fields. ID is an integer, auto incrementing, not null. Delivery name varchar, not null. Delivery address long text, not null, because addresses could be longer than the 255. Created that, we're happy with that. Cancelled that, we're happy with that. The difference between the two is that for cancel that, we obviously need to allow it to be null, otherwise it would have a cancel that date, meaning that the order's been cancelled on all the orders. Okay, and so I've also behind the scenes created the same for items. This one's a little bit more interesting. So auto incrementing ID, and we have our order ID, our product ID, which are both integers. We have the price. Created that is the same, and you'll see we have a couple of indexes have been created for us, which is nice. So we've got an index for order ID and an index for product ID, because that's going to be used in a foreign key, and this is where we see that. So it says alter table items, add constraint, and it gives like a foreign key, and it says foreign key order ID references orders ID. So it's creating our foreign key constraints for us, which is great, and it's done the same for the products table. And so our remaining step is actually to just go and run this. So we'll remove this dump SQL and we'll just run it. And this is good. This is a little bit of protection. Let's go and read what this says. It says, caution, this operation should not be executed in a production environment. Use the incremental update to detect changes during development use, blah, blah, blah. It says the schema tool would execute 4 queries to update the database. Please run the operation by passing one or both of the following operations. So use force to execute the command, or dump SQL, which is what we've just used to dump the SQL to the screen. So if we go and check in Table Plus and we refresh this, we've still only got 2 tables, so it hasn't actually run it. It's basically saying, be careful. Are you trying to do this in a production environment? Are you sure you want to make these changes to the database? So we are sure. Let's actually go and run this with force. So --force, hit enter. Okay, updating database schema, 4 queries were executed. Looking good. Let's go and refresh our... Okay, so we have an items table, an orders table, products table, and a users table. I'm fairly confident that they've been created correctly, but let's just go and check them in more detail. So items, I'm mainly looking at these ones here, order ID, and so it's saying we have a foreign key with the ID field on the orders table, same for products, and so that's looking good. And orders, can't see any problems with this because this one's fairly straightforward. ID, delivery name, delivery address created at, cancelled at, and it says that that field is nullable. So it's all been created exactly how I wanted it to be, and we can now move on to the next section. Okay, it's finally time, I think, to place an order. So let's remind ourselves of where we actually got up to on the front end. So I'm going to move from the project root into the public folder, and that's where I'm going to start up a local development server. So cd into public. Okay, and then php-s localhost 8000. And so we'll just run that. I'll go over, and our file that I'm looking for is this products view, and it was actually ID equals 1. Okay, and so we see our product page. It's very simple. I might make this up, put a picture on, etc. later on. And then what we wanted to do was just click buy it now, and that will take us to a single product page. And it has a query parameter that's using ID of 1 also. So let's go and have a look at our single product page and remind ourselves what we did there. So pretty basic. What we need here is we need to be able to enter an address. We need to be able to show the product that we are buying, or show some information regarding the product that we're about to click the place order button for. And we actually need to add some way of paying for the order. I'm not going to get into that right now. I'm going to do that later on. All I want to achieve at the moment is enter delivery name and delivery address details, so all the details which are required in the database to add an order, to add an item. And then I want to hit a place order button. Behind the scenes, it will go away, it will create the order, it will add items to that order, it will create items, it will add items to that order, add the order ID, product ID to the item, and then just display a success message saying your order has been placed, here is the ID. So if you think about what we need here, we need fields to add delivery addresses, mainly the product. We've already got information about the product because we're passing the ID as a query parameter, so we can just get the information that we need from the database in order to place an order. And in order to place an order, the item will need a price and we'll need a product ID for the item. And that is it, I think. So let's give this a go. What I'll start off by doing is just grabbing some of the PHP from our view PHP file. So we required Bootstrap and we decided to set a header. So I'll actually go and just paste some of this into there and see what we need. So I know we're going to need Bootstrap, Entity Manager. Okay, we're going to need information regarding the product. So we can use the same logic as what we've used there. Title, we're going to have actually set a different title, and this will be place order. Okay, so that will appear in the title at the top of the page on the little tab, and then I think we're happy with what we've got there. What we need is to actually put some HTML in our page. So let's go over to Bootstrap and do that. So here I am on Bootstrap, getbootstrap.com, and this is where I come for most of my examples. It's just good for rapid prototyping. People ask about Tailwind and stuff like that, but if you just want to get something built up quickly on a page, because after all, this is mainly a PHP course. It's not a HTML course or a CSS. So I just want the basics, or something that looks at least passable, that we can just plug in some PHP variables into. So let's have a look at some of these examples, and this one looks perfect. So checkout, let's hit this, and here we have a checkout form, and it's got information or fields where you can add a billing address. So that's perfect, that's just what we need. Payment stuff, okay, so we're probably going to use Stripe, I think, and that will provide its own payment page and its own payment field, so we can probably be able to just comment the payment stuff out. We've got a nice little bit over here where it tells you about your cart, and so we can also customize that. Okay, so I'm happy with what this looks like. It looks pretty good. Let's hit right click, view page source, and we'll just grab the whole lot for now and go over to our single product checkout. Underneath the closing PHP tag, we'll just paste that in there. And so it does a bit of validation for you. For example, if I try and submit this now, it does all this validation here, and it actually uses some JavaScript which comes with Bootstrap. So we'll actually grab the files for that, or we'll grab the CDN address for the Bootstrap files, and we'll also paste in a little bit of JavaScript at the bottom of our file. So let's go and have a look what that looks like. So it says we're looking for source equals form validation JS. Let's go and check that out. So all the way down here at the bottom, if you actually click on this, and then here you'll see a little bit of JavaScript. So we'll go and grab that. And we're just going to work through this slowly, line by line, and make sure we don't miss anything. So you'll just have to bear with me a bit on this. So we'll change this bottom script tag, and we'll just say type equals text JavaScript, and then paste that JavaScript in there. Okay, so that's good. And then the actual script tag for the JavaScript, we need to go and find that. So if you come back to the Bootstrap home page, so go to Bootstrap home, so you just add to getbootstrap.com, and then if you come down here, it has little links that you can click to copy both the CSS and the JavaScript to the clipboard. So we've already got the CSS because we are using that in the header, which we originally got when we did the view file. So just copy the JavaScript, go back to our single product checkout, and just above the script tag which we just added, where we added this little bit of custom JavaScript here, you'll see the script tag, and all you need to do is just replace that, and so now it's actually calling the CDN. Okay, and so let's go up to the top, and what we want to do is just from the opening HTML tag, just go all the way down, and we just want to remove this. We don't want the head, and we don't want the body. So down to where it says div class equals container. Let's remove that and go back over to Bootstrap, see what else we need to get from the source. So here is the source. Let's go up to the top, and here you'll see a link to form validation.css, which is in the head. Click on that, and there's just a little style here, container max width. So let's actually just go and look for our container. Div class equals container, and we'll just inline the style. So I think it was max width, and let's just remind myself what it was. I'll just paste that there a sec. 960px. So 960px. So that should do us for that. Let's actually go and check out what this looks like in our browser. So we'll refresh our checkout page. Okay, looking pretty good. What we need to do is just get rid of this here, because if you see in the page source, it's actually referencing something which we don't have, this docs 5.1 blah blah blah. What we'll actually do is the first image tag that you come to inside of the container, okay, just get rid of that. We don't need that. And then let's go and check this out again. Okay, getting there, we need a bit of padding at the top. So what we'll do is we'll actually add it here. So after where it says 960px, just add a semicolon and we'll say padding top equals 50px. Okay, one last go, I think. Alright, so that's better. We've still got our nav bar, because if you recall, what we've done here is inside of the PHP I've included the site header, and all our head and the CSS was all included in that, as well as the top navigation bar. So make sure that you are including that inside this PHP that we see at the top here. So I think we've got everything there. We've added our JavaScript. Let's actually go and try and submit this form without adding any information and see if the JavaScript is working. Alright, great. So it's adding all the styling and everything, so we now have a working form. In the next one, what we're going to do is start having a look at the stuff we want to keep, the stuff we want to get rid of, and just doing a little bit of customization. Let's go through this form and have a look at what we're going to keep and what we're going to get rid of. So first name, last name, what I'm going to do there is actually merge it and just have name. Okay, we don't need to have first name and last name. Let's keep this simple. Username, we don't need username at this point in time. It says that email is optional, so that means it won't get validated, and if I don't put one in, it won't fail validation, so we might as well leave that. And then it's split the address here, so what we'll need to do is, I quite like the idea of it being split and having like the street address and then city and country, etc. So we'll keep most of these. Country, as you can see, is a drop down. Let's keep it simple, and I'm just going to put that as an input, I think. State, probably get rid of that, and zip, we'll leave that the same. And so these little checkboxes here, we'll just leave them in. Obviously they're not going to do anything at the moment, but we'll keep them just in case we decide we want them later on. And payment, like I say, this bit we'll probably comment all the payment stuff out, and we'll not concern ourselves with this bit for the time being. Cart, what I want to do is just get the address bit working, so that I know we have the information that we require in order to create an order record, because we have a delivery address field and a delivery name field on the order. So let's focus on this, and then at least we know that once that bit's done, we can actually place an order, link an item to an order, and we know that we can actually test the dev side of things, the dev side of actually placing and linking items to an order. So I'm back in the single product checkout.php, and I'll put the line numbers in, which might make it a bit helpful, give you an idea. Your line numbers might not match up with mine exactly, but we should be in the right area. And what I've identified is that this div here is the one which surrounds all of our product information, i.e. this bit here, the cart, sorry. So what I want to do is just go and minimize this. I'm not commenting it out, I'm just going to minimize it, and so it'll make it a bit easier for me to figure out where everything else is. And then I have this line here. It was on line 74, but I've just moved it to 77 to give myself some space, and it is a div col md7 col lg7, and in here I'm just going to comment this as the beginning of billing address. And so we're just going to go through here and keep what we need, get rid of what we don't need. And so I said that I don't want first name, and so here as you can see it's col div class col sm6. Okay, if we just go and take that and remove that, I'm just going to go slow just to make it easier for everyone to follow along, because if I went fast on this, then people would definitely end up not being able to end up with the same thing as me. So we're on our next div class equals col sm6. So last name here inside of the label, I'm going to change that to name, and then you'll see label for last name, and then in the input you'll see the ID is also last name. Let's just change that to name, and then what I'm going to do is I'm going to give this input a name attribute, and this will be address and then brackets and then name. Okay, and then we'll just say this: valid name is required instead of valid last name is required. So there we have a div class equals col sm6 round about line 80. Mine's on line 82. Just make the changes that I've made there, and then we'll move on to the next one. So the next one is username. Okay, we've decided we're not going to have username, so where you see is div class equals col 12, just go down, find all of that and remove that. The next one is email, and this is optional, so we know it's not being validated when we submit the form, so I don't think there's any harm in just leaving that there for the time being. And then we have one, it is a div class equals col 12, and this is for address. We're actually going to call this street address. So street address. So we're going to change that label for and also the ID of the input to street address, and then the label itself, we'll change this to street address, and then input type equals text, ID equals street address. I'm just going to give this input a name attribute, and that will be address brackets street address. And with the brackets, I don't know if you've seen this before, but basically what it means is we'll have an address array with all different keys like street address, and then the value for street address. We'll have a key for address name, and obviously the name of the person that you're sending the delivery to. Okay, so enter your shipping address, and this next one here, div class equals col 12. This is going to be, we'll change this to town or city. Okay, so we'll paste that in there. City. So find address 2, label for address 2, and the ID of the input is address 2. Change that to city. We'll change this bit here where it says address 2 to city. Okay, and then just after the ID here, we need a name attribute, address, brackets, city. Okay, country. What I'd like to do with this is actually change this to an input, because I don't want to get into messy drop downs and having to have every country in the world in there. Let's just remove this entire select. So where you see the select tag, just remove that, replace it with an input, and then obviously we need to change this. So label for will stay as country, the ID of the input will become country, and the name will be address country. Okay, please select a valid country, and we'll change the wording of that from please enter a valid country, and where it says apartment or suite obviously needs to say country. So quite a bit to change there. So what we have, I'll check this out in the browser in a minute to see what the sizing looks like. So it's div class equals col md5. Find the one where it's said address 2. Okay, change all those bits. I think I've got everything there. State, don't think we need to bother with that. We'll just get rid of that and keep this simple. And then zip, so most of this should be able to stay the same. Let's just give it a name attribute. So name equals address, and then zip, square brackets. Okay, and these are your checkboxes. So we'll keep these as they are. They're not getting validated or anything, I don't think, when the form's submitted, so we can actually leave them as they are for now. Won't do any harm, we may use them later on. And so then we come to the section on payment. So you'll see this here. First you'll see a HR class equals my4, and then you'll see H4 class equals MB3 and the word payment. If you just find that And then what we'll do is we'll go all the way from the top of that, and we'll just find everything related to payments. So I'm seeing card numbers, expirations, CVV, security code, and then you'll actually get to the form submit button. So you'll end up with another HR class equals my4. Take that, cut it, and what I'm going to do is I'm actually going to keep it, but I'm going to drop it in below absolutely everything else and just comment it out. And then I know that if I do decide later on that I'm going to need some of this, I know exactly where it is, but it obviously won't be interfering with the work we've done because it's all commented out. Okay, so I think now we can actually go and just have a look, see what this looks like in the browser, and then make whatever changes we need to make from there. So I'll refresh and let's have a look. Name, that looks okay. I'll maybe make it the same size as these others just to match everything up. Street address, okay. City, obviously need to change the placeholder text there. It says apartment or suite. Country, that looks good. Zip, that looks good. Okay, so the two changes I'll make is I'll make this box longer, and I'll change the city placeholder text to say city rather than apartment or suite. So let's go and have a look at that. If I look for the word apartment, okay, city, and then we said we want to change the name. So name, as you can see, is col SM6. The others all appear to be col 12. Let's just copy one of those, and we'll go and just replace that with one of those. Okay, so where it said col SM6 for name, I've changed that to div class equals col 12. Let's go and actually refresh this. Okay, so name is the same length now. Email, city says city. Okay, so this form's looking better. In the next one, we'll actually start plugging in some values and making things work behind the scenes. Okay, what I'd like to do next is actually set up this form so that we can post it. We'll need to create a file which will handle that post, and then we also want to think about what data is missing from this form which we might need in order to create an item and create an order. And so the first things that I can think of are we're going to need some product information. So I'm thinking maybe we'll have a couple of hidden fields, one for the product ID, and we know we have a product ID because if we look at our PHP at the top here, we have a product ID, and also maybe the price, but we could also possibly just get that from the database. And so the line where the form begins for me is line number 79. It's where we actually start the billing address. So if you look for the text billing address, then you shouldn't go far wrong. So our method will be post, and then we need an action. So what I'm going to do is actually create a file which will handle this submission. So we'll go up into public and we'll create a file, a folder called orders. Okay, and inside of that, I'm just going to create a normal PHP file called place order. And then this will handle all of our data which is being posted, and we'll use that in order to figure out how we're going to create our entities and how we're going to save them in the database. So that is in public orders and then place order.php. Let's go back to our single product checkout. So action will be orders and then place order.php. Okay, I think that looks correct. Let's just drop this onto another line just to make it a bit easier to read. Then what I'd like to do is have some product information. So we know we have a product here because we're querying the database and we're getting a product. So from that, I'm going to take the ID and the price. I may not actually end up using the price. We may just go direct to the database and get it again, but we'll put it in here anyway. So this will be a hidden field, and the name, I'm going to call this product and ID, and I'll show you how we get the value. So value equals, and then we just echo out some PHP, and so what we need is the product get ID. Okay, so that's how it works. That's how you create a hidden field if you've not done that before. And then we need the price. So what we should get when we actually submit this form is we'll have a product array, and that will have a ID key with the obviously ID value and a price key with the product price. So get price for that. And then when we submit this form, what I'm going to do is I'm just going to dump out everything, all of the post data. So we'll go over to our placeholder file. What I'm going to do is actually grab this bootstrap line here, drop that in there, so it's the same line that we're using at the top of our single product checkout. And while we're here, we might as well add the header, and then we know that that step is taken care of. And then we just need to give the title a good name, so we'll just call it order success or order status, because things might fail. Okay, good. So what I want to do now is just dump out our post variable. So that should do us. Now we just need to fill in this form and submit it. I'll zoom through this and do it behind the scenes. And then I'll submit the form. And so we have a syntax error, unexpected end of file, placeorder.php on line 11. And it's a missing semicolon, I might have guessed. Okay, so let's go and actually run this again. Confirm resubmission. And now we have our arrays which I mentioned. So we have a product array with the keys of ID and price, and we have an address array with the keys of name, street address, city, country and zip. So that is submitting the way we want it to do. What we want to do now is actually sanitize the input, because users are entering this, so we don't want them to enter anything malicious which will get into our database or into our application. So we want to escape any HTML there, and then what we'll actually do is create entities and try and save them to the database and store them. Let's think of the steps involved in order to create an order and an entity. So we know we already have the product, but those two things need to be created. Let's go and have a look at an order first. So we'll look at our order entity, and this has it references items. So this should be fairly straightforward to create. We have a delivery name and we have a delivery address in our delivery array, and that is really the only information we're going to need, which is missing in order to create this. And let's have a look at item, which will be more complex. And so what we need to do here is we're going to need the product. So using our product ID, which we passed in our post request, we're going to need to use that ID in order to get a product from the database, because in order to actually store and create this item, we will need that record, or we will need that entity. And the same for order. So we're going to need to get the product from the database, create the order and persist the order, and that means that once that step has been taken care of, we can then create the item. So that is the order in which we need to work on this. Let's go back to our place order file, and so same as we did before, we will get an entity manager, and in order to have the auto completion, we shall say entity manager. Okay, that's great. Let's actually bring that in. Okay, and so let's get our product. So product. In fact, we have some code that we can use in our single checkout, single product checkout page, because I've already done this once. Let's go and get this. And then the product ID will be post product ID. So let's actually just make sure that that step is working first. In fact, what would be a good idea here would be to actually write out the steps. So first, obtain product, then we need to create and persist an order, we'll say object then, an order, and then we need to create and persist an entity. Okay, so let's actually dump out this product and make sure that that is what we are getting back. back over to our browser, refresh, continue. Okay, that's worked. We have a product with the ID of 1, so far so good. Happy with that. I'll just bump up the size so it makes it a little bit easier for you to read. Okay, we have a product. Now let's create and persist an order. So, order equals new order. Okay, and we'll do the same here. Simplify FQN order. And then we need to actually first set a delivery name and set a delivery address. So where do we get a delivery name from? Again, let's just dump out our post variable, and what I'm looking for here is the delivery. Okay, so that is under a key called address. Let's go and refresh the browser. Okay, so what I'm looking for is address name. And like I said, we're going to need to sanitize this in some way to make sure that no one is trying to submit script tags or anything like that. So what we'll do is we'll say delivery name equals, and then I'm going to use HTML entities. Okay, we pass our string into that, and then what we need to do is handle single quotes and double quotes. So ent quotes, and then we just need to say the encoding is UTF-8, and let's actually go and dump out the delivery name here. And then what I'll do is I'll put some malicious code in there, I'll put some script tags or something, and then we'll dump it out and I'll show you what actually happens to this. So I know this is like the stuff that you learn when you're doing procedural programming, but not everyone will remember it, and it is good to revise this kind of stuff every now and then, because when you're working with frameworks, etc., you'll find a lot of this stuff gets done for you and you forget all about it. And I did actually have to go and give myself a little reminder, did a bit of Googling on sanitizing input, so you can never practice this stuff enough. Okay, must be of type string array given. Let's have a look. Yes, because we need name, not address. So basically what that error is saying is that this part here, that is an array. So we need to actually also ask for the name key, which will give us back the name string. Okay, let's go back and give this another go. Okay, that's working. So I'm going to go backwards, and what I'm going to do is I'm just going to change this. I'm going to put a script. So I've now wrapped my name in script tags. Let's go and submit this. And as you can see, it's all been escaped. So there's nothing you could possibly try malicious there. It's handled it nicely. And so I think this will suffice for now. We are actually going to run some validation to make sure that we are entering the correct type of values into the database that we should be doing, but I'm going to show you a different way of doing that that we can use using Symfony components and adding annotations to our entities. So we'll come to that shortly, but for now I'm happy that we've secured our application to a certain extent, and so this is looking pretty good. And what we need to do now is do the same for delivery address. Now, if you remember, our address is made up of several parts. So what we need to do is concatenate all those parts, and then what we'll do is we'll use HTML entities to sanitize the entire thing. Okay, so delivery address. Here's just a little reminder of which fields we need to concatenate. They are street address, city, country, and zip. So behind the scenes, what I'll do is I'll go and build up a delivery address, which is all of those values concatenated. Okay, and so here is that we have street address and then a comma, then city, and then a comma, then country, and a comma, and then we have zip. Okay, and then we just need to do the same thing as what we did for delivery name. So let's borrow that, and we'll say delivery address equals, and we're just going to change this to delivery address, and that should work. So what we're going to do is actually dump this out and make sure that it's formatted the way that we expect it to do. Go back to the browser, refresh this. Okay, 123 Long Lane, London, blah blah blah. That's all formatted nicely. We know that our HTML entities is working. It is sanitizing the way we expect it to, so we don't need to go and check that. I'm happy with that. So now we can actually finish off building up our order. So I think what we'll do is we'll drop this part down here and we'll start from here. Okay, order, and we're going to set delivery name, and that will be delivery name, and then we shall say order set delivery address, and that will be delivery address. And then what we need to do is actually persist and then flush. So we definitely have to flush this in order to have the order, have an order ID available for us when we create an item. And I've just seen that this should actually say item and not entity. So entity manager, persist order. Okay, and that will bring it under the entity manager's control, letting the entity manager know about our order. In order to make it permanent, we need to say entity manager flush. Okay, and that should create us an order in the database. What we need to do now is take the information that we know regarding the product and regarding the order and create an item. So item equals new item. And again, we'll use a fully qualified name. And then item. So we need to set the price. And what we can do is use product get price. And then we need to say item set product. And that will be product. Then item set order. And that will be our order. And again, we need to say entity manager persist item, and then entity manager flush, and then that will go and execute all of the queries which are needed. So what we'll actually do to check that this has worked initially is we'll just dump out the two things which will confirm to us that records have been created, and that will be an order ID and also an item ID. So dd order get ID and also item get ID. Let's go and actually run this in the browser, and after we've done this, we'll actually go and look at the database to see if records have been created. Okay, 1 and 1. Let's run it again. 2 and 2. That is looking good. So let's go over to Table Plus and see if there are records in the database. Items, we have 2 records created in the database, and the timing looks pretty good, so I know that I'm happy with that. Orders, as you can see, 2 records created in the database for orders, and it's done everything we need it to regarding all the escaping, that's all there. So I think we can be reasonably happy with progress there. What we've done is we've submitted a checkout form, we've took the data, we've actually created an order, we've created items and linked them to the order. That's all pretty good. What we need to do is obviously tidy up our place order file. We need to show the user some kind of success feedback to say that an order has been placed, and we also need to validate the inputs we are saving in the database for our order and our entities. So I'll show you a pretty cool way that we can do that as well in the next one. If you've enjoyed this video and you'd like YouTube to show you more of my content, all you need to do is subscribe and click the notification icon. Each week I release a number of new recordings. If you'd like to be informed about my upcoming videos as well as receive exclusive content, discounts and early access to my new videos, you can join my mailing list by following the link underneath this video.